Close your eyes. Let your breathing slow. Tonight, we journey into the heart of one of humanity's most terrifying encounters with nature. This is a story that spans continents and decades, a story of microscopic terror and extraordinary courage. Stay with me through the darkness, and I promise you'll emerge understanding something profound about our fragile existence on this planet. The jungle doesn't care about you. It never has, and it never will. Deep in the emerald shadows of Central Africa, where the Ebola River winds through dense rainforest like a dark vein, something ancient has been waiting. Waiting in the blood. Waiting in the cells. Waiting for the perfect moment to remind humanity that we are not the apex predators we believe ourselves to be. The year was 1976, and the world had no idea what was coming. Picture a small village in northern Zaire, now known as the Democratic Republic of Congo. The morning mist clings to thatched roofs. Children laugh, playing in red clay dirt. Women carry water from the river. Life moves in its ancient rhythms, as it has for thousands of years. But something has changed. Something invisible. Something deadly. His name was Mabelo Lokila, a 44-year-old schoolteacher who had recently returned from a trip to the northern border region. On August 26th, he walked into the Yambuku Mission Hospital complaining of a fever. Just a fever. Nothing unusual in equatorial Africa, where fevers come and go like the afternoon rains. The Belgian nuns who ran the hospital gave him an injection of anti-malarial drugs. Standard procedure. They used the same syringe they'd been using all morning, sterilizing it in warm water between patients. Back then, nobody thought twice about it. Mabelo went home. But the fever didn't break. Instead, it got worse. His head pounded like drums. His muscles ached. His joints screamed with pain. Within days, he couldn't keep food down. The vomiting was relentless. Then came the diarrhea, black as oil. His eyes turned red, the whites bleeding into crimson pools. His skin felt like it was on fire from the inside out. On September 8th, 13 days after that first injection, Mabelo Lokila died. The nurses who attended him washed his body according to traditional customs. They touched his skin. They handled his fluids. They had no protective equipment, no masks, no gloves, no concept of what they were dealing with. Within weeks, the hospital became ground zero for something the world had never seen. Nurses began falling ill with the same terrifying symptoms. Teachers, family members, anyone who had touched the sick. The disease spread through the hospital like wildfire through dry grass, and nobody understood why. These weren't just fevers anymore. People were hemorrhaging, bleeding from their eyes, their noses, their gums. Blood seeped from injection sites. Internal organs liquefied. The human body was essentially digesting itself from within. Sister Miriam, a Belgian nun who had dedicated her life to healing, fell ill. Sister Romana. Sister Edmonda. One by one, the very people trying to save lives became victims. The mission hospital had 5 syringes that they reused hundreds of times each day. Every injection was potentially a death sentence, though nobody knew it yet. The syringes weren't weapons. They were supposed to be tools of healing. But in the hands of an invisible enemy, they became instruments of mass transmission. The villagers started calling it the disease that kills everyone. Panic rippled through the region. People fled into the jungle, carrying the disease with them. Traditional healers tried their remedies. Nothing worked. Prayer services were held. The sick grew sicker. The dead piled up faster than graves could be dug. Somewhere in a lab thousands of miles away, scientists were about to receive the shock of their lives. On September 27th, a commercial flight landed in Kinshasa carrying blood samples packed in a blue thermos filled with ice. The samples had been collected from Sister Miriam and several other patients. They were supposed to go to laboratories in Europe and America for analysis. Nobody on that plane knew they were transporting one of the most lethal viruses known to science. The samples arrived at the Institute of Tropical Medicine in Antwerp, Belgium, and at the Centers for Disease Control in Atlanta, Georgia. Researchers placed drops of the infected blood onto cell cultures, expecting to find yellow fever, or maybe Lassa fever, or perhaps some strain of typhoid. What they found instead would rewrite the textbooks on infectious disease. Under electron microscopes, the virus appeared like something from a nightmare. Long, thread-like structures twisted into bizarre shapes. Some looked like question marks. Others resembled the number 6. Some were branched like dead trees. The virions measured up to 1,400 nanometers in length, making them among the largest viruses ever discovered. They had a distinctive structure, unlike anything in the viral databases. Dr. Peter Pyatt, a young Belgian microbiologist, was part of the team examining the samples. Years later, he would recall the moment with crystalline clarity. The microscope revealed a filovirus, a family so rare that only one other member had ever been identified. Marburg virus, discovered in Germany in 1967. But this was different. This was new. This was absolutely terrifying in its lethality. The virus needed a name. The researchers gathered around a map of Zaire, looking for inspiration. They didn't want to name it after the village of Yambuku, fearing the stigma would devastate the already traumatized community. Their eyes settled on the Ebola River, a tributary near the outbreak zone. The name sounded mysterious, ancient, powerful. Ebola virus disease was born into scientific nomenclature. But naming it didn't stop it. Back in Yambuku, the nightmare continued. By early October, the outbreak had claimed over 300 lives. The mission hospital shut down completely. The nuns who survived fled. The building stood empty, windows dark, a monument to good intentions and tragic ignorance. The mortality rate was staggering. 88% of those infected died. For every 100 people who caught this disease, only 12 survived. And those 12 were changed forever. If you're still listening, take a deep breath. Let the weight of these numbers settle over you like a blanket. 300 dead in one small corner of the world, and the world barely noticed. But stay with me, because this story is just beginning, and there are secrets yet to unfold that will make your skin prickle with recognition of just how fragile our modern world truly is. An international team assembled with remarkable speed. Scientists from the CDC, the World Health Organization, Belgian researchers, and Zairean doctors formed a task force. They flew into the outbreak zone with limited supplies and unlimited fear. Most had never dealt with anything remotely this deadly. They were walking into the unknown, armed only with scientific curiosity and an obligation to stop the dying. Dr. Pierre Serrault, a French virologist, later described entering Yambuku as stepping into a ghost town. Homes abandoned. Streets empty. The smell of death lingering in the tropical air. The team set up a makeshift laboratory in one of the few remaining functional buildings. They worked in sweltering heat, wearing whatever protective equipment they could improvise. This was before modern biosafety suits. Before standardized protocols. They were making it up as they went along, knowing that one mistake could cost them their lives. The investigation revealed a pattern of transmission that was both simple and horrifying. The virus spread through direct contact with bodily fluids. Blood, vomit, diarrhea, sweat, semen, breast milk. Every fluid the human body produces could carry billions of viral particles. Caring for the sick meant exposing yourself. Preparing the dead for burial meant touching contaminated bodies. Traditional funeral rites, which involved washing and embracing the deceased, were perfect vectors for transmission. But the real amplifier was the hospital itself. Those 5 syringes had been used on thousands of patients. A woman would come in for a vitamin injection and leave with a death sentence coursing through her veins. A child receiving antibiotics would carry home an invisible killer. The hospital, meant to heal, had become the epicenter of an epidemic. This pattern would repeat itself again and again in future outbreaks, healthcare settings turning into killing fields. The team implemented brutal but necessary measures. They established a cordon sanitaire, a quarantine zone around the affected area. Nobody in, nobody out. Soldiers enforced the blockade. Families were separated. The sick were isolated. Those who tried to flee were turned back at gunpoint. It sounds harsh, and it was, but it worked. By cutting off transmission routes, the outbreak began to slow. The disease had to run its course through the population. Those who were infected either died or recovered. There was no treatment, no cure, no vaccine. The medical team could only offer supportive care, fluids, pain management, comfort in dying. They documented everything meticulously, taking samples, recording symptoms, tracking transmission chains. Science working in real time against an unknown enemy. By November, new cases stopped appearing. The outbreak had burned itself out. The final tally, 318 cases, 280 deaths. An entire region traumatized. But the team had learned invaluable lessons about how the virus spread and, crucially, how to stop it. Here's where the story gets really interesting, and you need to pay attention because this detail changes everything we thought we knew. While the team was still working in Yambuku, a second Ebola outbreak began 400 miles away in a completely different location. Same country, same time frame, but a different strain of the virus. On June 27, 1976, 2 months before Mabelo Lokila felt his first fever, a man in Zara, South Sudan, fell ill. The town sits near the border with Zaire and Uganda, in a region of savannas and cotton fields. The outbreak started in a cotton factory, where workers handled raw cotton imported from various regions. The disease spread quickly among the factory workers and their families. This strain behaved slightly differently. The mortality rate was lower, around 53%. Still catastrophic, still terrifying, but not quite as universally lethal as the Zaire strain. Scientists would later classify this as Sudan Ebola virus, a distinct species within the Ebola virus family. The outbreak claimed 151 lives before it too burned itself out. 2 outbreaks, 2 different strains, same year, thousands of miles apart. The implications were staggering. This wasn't a single, isolated incident. Ebola virus existed somewhere in nature, in some reservoir host that humans occasionally encountered. But where? And in what animal? These questions would haunt researchers for decades. Let your mind drift now, imagining the vast green canopy of the African rainforest. Somewhere in that biological cathedral, in the blood of some bat or primate or unknown creature, the virus waits. Always waiting. Always ready. As you listen, researchers are still searching for the complete answer. But we're getting ahead of ourselves. First, we need to talk about what happened next. If you're finding this journey fascinating, if you're feeling that delicious pull of dark history wrapping around your consciousness, do me a favor, hit that subscribe button for dreamless timelines. Let this channel be your companion through the shadowy corridors of the past. Leave a comment telling me what fascinates you most about these stories. And definitely smash that like button, because it helps more people find these deep dives into history's darkest corners. Now, let's continue into the silence that followed those first outbreaks. For 3 years, Ebola vanished. Not a single confirmed case. The virus seemed to have retreated back into whatever hidden reservoir it emerged from. Scientists wondered if they'd seen the last of it. Maybe it was a one-time event, they thought. Maybe the virus would never resurface. They were so very wrong. 1979. A man named Charles Akalango worked as a mechanic at a sugar factory in Zara, Sudan, the same town where the 1976 outbreak occurred. On July 30th, he developed a fever. Then came the hallmark symptoms: vomiting, diarrhea, bleeding. He died on August 8th. The virus was back. This outbreak was smaller, only 34 cases, but the message was clear: Ebola hadn't disappeared. It lived somewhere in the ecosystem, cycling through its natural host, occasionally spilling over into human populations when conditions aligned. The World Health Organization responded quickly this time, having learned from the previous outbreaks. They isolated patients, traced contacts, enforced infection control. The outbreak was contained within weeks. Then, another long silence. No cases in 1980, or 81, or 82. The years slipped by. Ebola became a footnote in tropical medicine textbooks. A curiosity. A boogeyman that had briefly emerged and then retreated. Research funding dried up. The sense of urgency faded. The world moved on to other concerns. But in the deep forest, the virus waited. 1994. The place, Tai National Park in Côte d'Ivoire. A Swiss ethologist named Christophe Bosch had been studying chimpanzees in the park for years, documenting their behavior and social structures. It was painstaking work, requiring long hours of observation in the forest. His team had come to know individual chimps, naming them, understanding their personalities. In November, members of the research team noticed something disturbing. Dead chimpanzees. Not one or two, but many. Bodies scattered through the forest, decomposing rapidly in the tropical heat. Necropsy of the bodies revealed they died from some kind of hemorrhagic illness. Their organs showed the telltale signs of massive tissue damage. On November 5, a 34-year-old female veterinarian who was part of the research team performed a necropsy on one of the dead chimpanzees. She wore gloves and took basic precautions, but this was a wildlife study, not a biohazard operation. She touched the chimp's organs, examined its tissues, took samples. 10 days later, she fell ill. High fever, severe headache, muscle pain. She was evacuated to Switzerland, where she was admitted to the hospital in Basel. The doctors were baffled. Her symptoms didn't match anything they recognized. Blood samples were sent to specialized laboratories. When the results came back, the medical team went into overdrive. Ebola, but not the Zaire or Sudan strains. This was something new, Thai forest Ebola virus, also called Côte d'Ivoire Ebola virus. The woman was placed in strict isolation. The hospital implemented the highest level of infection control protocols. This was Switzerland, one of the most developed healthcare systems in the world, and they were terrified. Against all odds, she survived. She was one of the lucky ones, recovering fully after weeks of intensive treatment. But her case proved something crucial. Ebola's natural reservoir included wild chimpanzees, either as hosts or as victims like humans. The virus was circulating in primate populations across Central and West Africa. But here's what should keep you awake, what should make your skin prickle with existential dread. If a researcher working with all the advantages of modern science, with medical evacuation and world-class treatment, barely survived, what chance did villagers in remote Africa have? What chance did anyone have if this virus ever found its way into a major population center? The answer would come soon enough, and it would be worse than anyone imagined. Feel your eyelids growing heavy, but don't drift off just yet. The story is about to enter its most devastating chapter. The outbreak that would change everything. The outbreak that would force the world to finally pay attention. 1995. Kikwit, Zaire. A city of 200,000 people, connected by roads and trade routes to the rest of the country. Not a remote village. Not an isolated settlement. A real urban center. When Ebola arrived there, it arrived with the potential to spread faster and further than ever before. April 6th. A 36-year-old charcoal maker named Kim Fumu fell ill after working in the forest. He thought it was malaria. His family took him to Kikwit General Hospital. The medical staff gave him the usual treatments. Anti-malarials. Intravenous fluids. But he didn't improve. His condition deteriorated rapidly. Blood seeped from his injection sites. He vomited black fluid. On April 10th, he died in agony. The medical staff who treated him started falling ill. Nurses, doctors, lab technicians. One after another, they developed fevers, then hemorrhaging, then organ failure. The hospital's maternity ward was hit particularly hard. Women came to give birth and left in body bags. Newborns lost their mothers. Husbands lost wives. The hospital descended into chaos. By early May, over 100 healthcare workers had been infected. The mortality rate was astronomical. Entire hospital wards shut down. Patients fled. Families barricaded themselves in their homes. The city's economy ground to a halt. Markets closed. Businesses shuttered. Fear became the only currency that mattered. The international response this time was massive and swift. Teams from the CDC, Médecins Sans Frontières, the World Health Organization, and other agencies converged on Kikwit. They brought proper equipment, protective suits, guidelines developed from previous outbreaks. They set up isolation wards, trained local staff, implemented contact tracing. Dr. Pierre Rollin from the CDC led much of the ground response. He later described Kikwit as a waking nightmare. The isolation wards were sweltering. Patients lay on plastic sheets, hemorrhaging from every orifice. The sounds were unbearable, moaning, crying, the wet rasp of lungs filling with fluid. Healthcare workers in full protective gear looked like aliens, which terrified patients even more. The team worked 20-hour days in 100-degree heat. The protective suits were suffocating. After an hour inside, you were drenched in sweat, disoriented from heat exhaustion, desperate for water. But you couldn't remove the suit until you'd gone through elaborate decontamination procedures. One mistake, one tear in the fabric, one moment of carelessness, and you could join the patients you were trying to save. Despite the horror, there were moments of profound humanity. Nurses who'd recovered from Ebola volunteered to care for the sick, knowing they were now immune. Mothers cradled dying children. Religious leaders defied quarantine orders to pray with the afflicted. Humanity's capacity for compassion shone through even in the darkest hours. The outbreak lasted until August. 315 cases. 254 deaths. 81% mortality. Kikwit became synonymous with Ebola, the way Yambuku had 2 decades earlier. But this time, the world was watching. International media covered the outbreak extensively. Images of patients in isolation wards, healthcare workers in hazmat suits, mass graves being dug in the red earth, these images seared themselves into global consciousness. Ebola was no longer an obscure tropical disease. It was a household name, a terror, a reminder that nature still held cards we couldn't trump. Take a moment. Breathe slowly. In through the nose, out through the mouth. The story continues to darken before it finds any light. There are twists ahead that will surprise you, tragedies that will move you, and revelations that will change how you see the invisible world around you. Remember to like this video if the story is drawing you in. Comment below about which aspect of this history affects you most. And subscribe to Dreamless Timelines for more journeys into the forgotten and terrifying corners of our past. Your support keeps these stories alive. The pattern was now clear to researchers. Ebola outbreaks followed predictable triggers. Hunting in the forest, butchering bushmeat, contact with sick or dead animals, healthcare settings with poor infection control, traditional burial practices involving washing and touching the dead. Every outbreak taught new lessons about transmission, but those lessons came written in blood. Between 1995 and 2013, smaller outbreaks flickered across Central Africa like dark flames. Gabon, Republic of Congo, Uganda, each one slightly different. Different strains, different attack rates, different settings, but always the same core horror, a virus that turned the human body into a factory of its own destruction. In 2000, a major outbreak struck Gulu, Uganda. This was the Sudan strain, rearing its head again after years of dormancy. The outbreak began in September and raged for 4 months. 425 cases. 224 deaths. The Ugandan government, having learned from previous disasters, responded aggressively. They quarantined affected areas, banned traditional burials, enforced strict hospital protocols. One particular story from Gulu illustrates the impossible choices Ebola forces upon people. A nurse named Matthew Luquia headed the medical response at St. Mary's Hospital Lacer. He was beloved in the community, known for his skill and compassion. As the outbreak intensified, he insisted on treating patients himself, showing his staff that it could be done safely with proper precautions. On November 30, 2000, Dr. Luquia was examining a patient when some blood splashed into his eye. Just a drop. A fraction of a milliliter. He immediately washed the eye and reported the exposure. 14 days later, he developed a fever. He knew exactly what it meant. He isolated himself immediately to prevent spreading the disease to others. His colleagues pleaded to let them care for him, but he refused. He didn't want anyone else exposed on his account. He died on December 5, a hero who sacrificed everything to save others. His story spread through the medical community worldwide. He became a symbol of the incredible bravery required to fight Ebola on the front lines. Let that sink in as you rest. A single drop of blood in the eye. That's all it took. One moment of bad luck, and a good man died. This is the enemy we're talking about. Invisible, patient, absolutely lethal. The early 2000s saw scattered cases and small clusters. A few cases here. A handful there. The virus remained endemic in certain regions of Africa, a constant background threat. Researchers continued searching for the natural reservoir. They tested thousands of animals. Bats, primates, rodents, pigs, antelopes, anything that might harbor the virus. The breakthrough came in 2005. A team of researchers published findings showing that 3 species of fruit bats, hammer-headed bats, Frankwitz epaulet fruit bats, and little collared fruit bats, carried Ebola virus genetic material and antibodies without showing signs of disease. These bats were asymptomatic carriers. They could host the virus, replicate it, and shed it in their saliva, urine, and feces without dying. The pieces started fitting together. Fruit bats range across the tropical regions of Africa. They roost in colonies, sometimes thousands strong. They travel long distances to find fruiting trees. Their droppings contaminate fruit that falls to the forest floor. Other animals, chimps, gorillas, duikers, porcupines, eat the contaminated fruit or come into contact with bat excrement. They become infected. Humans hunting these animals or finding their carcasses get exposed. The spillover event occurs. It was an elegant explanation, though not completely proven. The virus maintained itself in bat populations, occasionally jumping to other species, eventually reaching humans. The bats weren't evil. They weren't trying to hurt anyone. They were just living their lives, and sometimes those lives intersected with ours in catastrophic ways. But knowing the reservoir didn't stop the outbreaks. In fact, the outbreaks were about to get much, much worse. Your breathing should be slow now, deep, rhythmic. The story is carrying you forward like a dark river. There's no turning back now. We're approaching the big one. The outbreak that broke all the rules. 2013, December. A 2-year-old boy named Emile Wamuno lived in the village of Miliandu in southeastern Guinea. He played in the forest near his home like all the village children. Near his house stood a large tree where a colony of bats roost. Emile might have played near that tree, might have touched bat droppings, might have eaten fruit contaminated with bat saliva. We'll never know the exact moment of transmission. On December 26th, Emile developed a fever. His mother cared for him at home, as mothers do. 2 days later, he died. His sister fell ill shortly after and died. Then his mother. Then his grandmother. One by one, the family was wiped out. The disease spread to nearby villages. Then to towns. Healthcare workers became infected. Traditional healers. Market vendors. Truck drivers. The virus moved along roads and trade routes, hitching rides in the bloodstreams of unsuspecting carriers. By March 2014, cases were appearing in Guinea's capital, Conakry, a city of nearly 2 million people. But here's where this outbreak diverged from all previous ones. It didn't stay in one country. Ebola crossed borders. Guinea shares boundaries with Liberia and Sierra Leone. People move freely across these borders. Family ties span nations. Trade flows in all directions. When Ebola entered this interconnected region, it found perfect conditions to spread. By June 2014, the World Health Organization admitted the outbreak was out of control. It had spread to 3 countries. Cases were appearing in capital cities. The healthcare systems, already weak from years of civil war and underdevelopment, were collapsing under the strain. This was no longer a containable outbreak in a remote village. This was an epidemic that threatened to consume West Africa. The numbers climbed with sickening speed. 50 cases became 100. 100 became 500. 500 became 1,000. Every week brought new records, new horrors, new evidence that the international response was too little, too late. Médecins Sans Frontières, the organization with the most experience fighting Ebola, sounded the alarm. Their president, Dr. Joanne Liu, gave speeches warning that the world was losing this fight. She begged for military intervention, for massive resource deployment, for a response commensurate with the threat. Initially, her warnings were ignored. People in affected countries faced impossible situations. In Monrovia, Liberia's capital, the few Ebola treatment centers filled to capacity. Sick people were turned away. Families watching loved ones die at home, knowing that if they called for help, the patient would be taken to a place they'd never return from. Body collection teams, dressed in protective gear, roamed the streets picking up corpses. The living hid the dead to avoid the stigma and fear that followed Ebola. Healthcare workers died by the hundreds. They were the heroes on the front lines, but they paid a terrible price. Dr. Sheikh Humar Khan, Sierra Leone's leading virologist and one of the country's foremost Ebola experts, contracted the virus while treating patients. He died in July 2014. His death devastated the medical community. If someone with his knowledge and experience couldn't survive, what hope did ordinary people have? Feel the weight of that question. Let it press down on you gently. These aren't just statistics. These were people with families, dreams, fears. Each number represented someone who laughed, loved, hoped. Keep that in mind as the numbers grow larger. By August, the outbreak had claimed over 1,000 lives. The WHO declared it a public health emergency of international concern, their highest level of alert. The declaration came too late. The virus had already established itself in multiple major cities. It was spreading exponentially. Then came the game changer: international cases. On July 20th, a Liberian-American man named Patrick Sawyer flew from Monrovia to Lagos, Nigeria. He was feeling ill but convinced himself it was malaria. He collapsed upon arrival at the airport. He was taken to a hospital, where he died 5 days later. His diagnosis: Ebola. Lagos is a megacity. 18 million people packed into one of Africa's largest urban areas. If Ebola established itself there, the consequences would be catastrophic beyond imagination. The Nigerian government launched an unprecedented response. They traced every single person who'd had contact with Sawyer: hospital staff, airport workers, family members, other passengers. They monitored temperatures. They quarantined contacts. They educated the public. Against all odds, Nigeria contained the outbreak. Only 19 cases total, 8 deaths. It was a massive success story, proving that with sufficient resources and political will, Ebola could be stopped even in densely populated areas. But the lesson came at a cost: those 8 deaths, including some of the medical staff who'd treated Sawyer. Meanwhile, in Guinea, Liberia, and Sierra Leone, the epidemic raged on. September 2014 saw over 1,000 new cases per week. Schools closed. Economies collapsed. International flights were cancelled. Countries implemented travel bans. Fear spread faster than the virus itself. The international community finally mobilized. The United States sent troops to Liberia to build treatment centers. The UK deployed to Sierra Leone. France sent aid to Guinea. Cuba, despite its limited resources, sent hundreds of doctors and nurses, one of the largest medical deployments in the response. NGOs poured in resources. Treatment centers sprouted across the affected countries. But even with help, the situation remained dire. Treatment centers were hellish places. Patients lay in beds, separated by plastic sheeting. The heat was unbearable. The smell of bleach mixed with vomit and feces created a nauseating miasma. Healthcare workers rotated shifts, spending only an hour at a time in the protective suits before heat exhaustion forced them out. Survival rates improved slightly as medical teams learned better supportive care techniques. Aggressive rehydration, electrolyte management, treating secondary infections, careful monitoring. With proper care, the mortality rate dropped from 90% to around 60%. Still catastrophic, but it meant more people surviving than in previous outbreaks. 60%. Imagine flipping a coin, but if it lands on one side, you die a horrible death. That's what Ebola survivors faced. Now breathe deeply and let yourself marvel at the courage of those who fought this disease knowing those odds. Make sure you're subscribed to Dreamless Timelines. Hit that notification bell so you never miss another journey into the shadows of history. Drop a like if this story is keeping you engaged. Your support means everything. One of the most moving aspects of the epidemic was the survivors. People who'd been to the edge of death and somehow clawed their way back. They emerged weak, traumatized, but immune. Many of them volunteered to care for the sick, knowing they couldn't be infected again. They became known as Ebola survivors, wearing the title like a badge of honor and carrying the psychological scars like invisible wounds. But survival came with costs. Many survivors experienced what came to be called post-Ebola syndrome. Joint pain, vision problems, fatigue, memory issues. The virus could persist in immune-privileged sites, the eyes, the testes, the central nervous system, for months after recovery. Male survivors were warned that they could potentially transmit the virus through sexual contact for up to a year after recovery. There were documented cases of transmission through semen months after the donor had recovered. In Liberia, a woman contracted Ebola in March 2015, long after the epidemic had seemingly ended in her area. Genetic sequencing traced her infection back to a sexual partner who'd recovered from Ebola 6 months earlier. The virus had been hiding in his body all that time, waiting. This revelation was terrifying. It meant Ebola could smolder in survivors, potentially reigniting outbreaks months or years later. It meant that even after an outbreak appeared over, the threat remained. It changed everything about how public health officials had to approach post-outbreak monitoring. Survivors also faced social stigma. Communities feared them. Employers wouldn't hire them. Spouses left them. Children were bullied at school. Despite being immune and posing no threat, they were treated as pariahs. The psychological toll was immense. Some survivors attempted suicide. Support groups formed to help them cope with the trauma and rejection. Yet through all this darkness, there were incredible stories of resilience. A nurse in Liberia named Josephine Karwa survived Ebola after watching her parents die from the disease. She lost her job due to stigma but became an advocate for survivors, speaking internationally about her experience. She helped other survivors navigate the difficult path back to normal life. Tragically, she died in 2017 from complications related to childbirth, the healthcare system failing her in a different way. Dr. Kent Brantley, an American physician working in Liberia, contracted Ebola while treating patients. He was evacuated to the United States, becoming one of the first patients treated on American soil. His arrival sparked panic. The plane that carried him landed in Atlanta under tight security. He was rushed to Emory University Hospital's Special Isolation Unit. The media covered every moment. Dr. Brantley received ZMapp, an experimental antibody treatment that had never been tested in humans. It was a Hail Mary, a desperate attempt to save his life using unproven medicine. He also received a blood transfusion from a 14-year-old Ebola survivor from Liberia. The antibodies in that survivor's blood might have helped his immune system fight the virus. Against all odds, Dr. Brantley survived. He recovered fully and later testified before Congress about his experience. His survival raised thorny ethical questions. Why did an American doctor get access to experimental treatments while thousands of Africans died without even basic care? The disparity highlighted global inequities in healthcare access and sparked necessary conversations about medical ethics during epidemics. Other international cases followed. A Spanish nurse who treated an infected priest contracted the disease. She survived after intensive treatment. A British healthcare worker fell ill and was flown back to London for treatment. She recovered. These cases were handled differently than those in Africa, with cutting-edge medical care, specialized facilities, and resources that most of the world could never access. Let yourself feel the injustice of that. Close your eyes and imagine being sick in a place where help simply doesn't exist, where your life's value is measured by where you were born. It's a thought that should disturb your rest. The epidemic continued through 2014 and into 2015. Each month brought grim milestones. 5,000 dead. 10,000. 15,000. The numbers became abstract, too large to comprehend as individual tragedies. Behind each number was a person, a story, a family destroyed. By mid-2015, the tide finally began to turn. The massive international response was working. New treatment centers meant patients could be isolated and cared for properly. Public education campaigns taught communities how to protect themselves. Safe burial teams ensured that funeral practices didn't spread the disease. Contact tracing improved. The exponential growth stopped. Cases began to decline. Slowly at first, then more rapidly. Weeks would pass without new infections in certain districts. Then entire counties would be declared Ebola-free. The green zones expanded while the red zones shrank. On May 9, 2015, Liberia was declared Ebola-free. The country erupted in celebration. People danced in the streets. Churches held services of thanksgiving. For 42 days, no new cases had been reported. The nightmare seemed to be over. But it wasn't. Not yet. Just 6 weeks later, on June 30th, a 17-year-old boy died in Margibi County, Liberia. He tested positive for Ebola. The virus was back. Genetic analysis showed his strain was closely related to earlier outbreak strains, suggesting the virus had been hiding somewhere, possibly in a survivor. The flare-up caused 5 additional cases before being contained. This pattern repeated itself. Sierra Leone was declared Ebola-free on November 7, 2015. Guinea followed on December 29. Each time, celebrations were muted by the knowledge that flare-ups remained possible. And indeed, both countries experienced small resurgences in early 2016 before finally, truly, beating the epidemic. On March 17, 2016, Liberia was declared Ebola-free for the third and final time. On June 1, Guinea joined them. The WHO officially declared the end of the public health emergency on March 29, 2016. The West African Ebola epidemic, the largest and deadliest in history, was over. The final count was staggering: 28,600 cases, 11,310 deaths. These were just the official numbers. The true toll was likely higher, as many cases went unreported in remote areas or in the chaos of the epidemic's peak. Entire families wiped out. Thousands of children orphaned. Healthcare systems decimated. Economies shattered. The scars would take generations to heal. But the epidemic left behind more than scars. It left behind knowledge. Lessons written in blood but crucial for the future. The world learned that Ebola could spread in urban areas, that it could cross borders and threaten multiple countries simultaneously, that early intervention was everything, that healthcare workers needed proper equipment and training, that communities had to be involved in the response, that traditional practices needed to be respected while being adapted for safety. The epidemic also accelerated research in ways that might have taken decades otherwise. Before 2014, there was no Ebola vaccine. The disease was too rare to justify the massive investment required for vaccine development. Pharmaceutical companies couldn't make money on a vaccine for a disease that affected a few hundred people every few years. But the West African epidemic changed that calculus. When the death toll started climbing, when international cases appeared, when the threat of a global pandemic became real, suddenly money and resources poured into vaccine research. Let your mind settle on that bitter truth. It took thousands of deaths before the world decided African lives were worth saving with a vaccine. Feel that weight, but don't let it disturb your rest too much. The vaccine came, eventually. That's what matters now. The leading candidate was called RVSV-ZBOV. It was a genetically engineered vaccine that used a livestock virus called vesicular stomatitis virus as a vector. Scientists had removed one of the VSV genes and replaced it with a gene from Ebola that coded for the virus's outer glycoprotein. When injected, the vaccine couldn't cause Ebola, but it trained the immune system to recognize and attack the real virus. The vaccine had been sitting on a shelf in Canada for years. It was developed by the Public Health Agency of Canada in the early 2000s, but had never moved past animal trials because there was no commercial interest. When the epidemic hit, the license was transferred to pharmaceutical companies who could manufacture it at scale. Clinical trials had to move at unprecedented speed. Normally, vaccine development takes 10 to 15 years. They had months. The trials were conducted in Guinea using a clever design called ring vaccination. When a new case was identified, everyone in that person's ring of contacts, family, friends, neighbors, healthcare workers, was offered the vaccine. Half the rings were vaccinated immediately, half after a 3-week delay. This allowed researchers to measure the vaccine's effectiveness while ensuring everyone eventually got protection. The results were stunning. The vaccine was 100% effective at preventing Ebola in those who received it. Not 95%. Not 98%. 100%. Among the thousands of people vaccinated in the trial, not a single person who received the vaccine and had time for it to take effect developed Ebola. It was a medical miracle. Dr. Marie-Paul Keeney, the WHO's Assistant Director General, announced the results in July 2015. She could barely contain her excitement. An effective vaccine will be another very important tool for both current and future Ebola outbreaks, she said. But privately, she wept. Wept for what this vaccine could have prevented if it had existed years earlier. Wept for the 11,000 people who died before science caught up with the crisis. The vaccine wasn't perfect. It required extremely cold storage, which was challenging in tropical climates without reliable electricity. The initial immune response could cause flu-like symptoms. Some people developed joint pain. But these were minor inconveniences compared to Ebola itself. The vaccine worked, and that changed everything. Breathe deeply. Feel the relief of that breakthrough. After all the death, all the suffering, finally something that could prevent infection. It's a small light in the darkness, but light nonetheless. If you're still with me on this journey, if you're finding value in understanding how humanity confronted one of nature's most terrifying weapons, show your support. Subscribe to Dreamless Timelines. Like this video. Share it with someone who appreciates deep historical narratives. Comment below about what aspect of this story resonates most with you. These small actions help keep this channel alive and growing. The post-epidemic world had to grapple with what had happened. Investigations were launched. Reports were written. Blame was assigned. The WHO came under heavy criticism for its slow initial response. Internal documents revealed that the organization's regional offices in Africa had downplayed early warnings, worried about the economic impact of declaring an emergency. By the time they acknowledged the severity, the virus had already spread too far. The healthcare systems in Guinea, Liberia, and Sierra Leone had been gutted. Hundreds of doctors and nurses had died, between 5 and 10% of each country's entire healthcare workforce. Hospitals that had shut down during the epidemic struggled to reopen. People who'd learned to fear hospitals during Ebola now avoided them even for routine care. Maternal mortality rates spiked as pregnant women delivered at home rather than risk going to medical facilities. The economic cost was estimated at over $53 billion across the 3 most affected countries. Not just the direct costs of the epidemic response, but the lost productivity, the collapsed businesses, the scared-away investment, the devastated agriculture sector. The World Bank estimated it would take years for the economies to recover to pre-epidemic levels. But there were positive changes too. The epidemic highlighted the desperate need for stronger health systems in developing countries. International organizations pledged billions to improve healthcare infrastructure in Africa. New rapid response teams were created, trained to deploy at the first sign of an outbreak. Disease surveillance systems were strengthened. The global health security agenda gained momentum, with countries worldwide committing to better prepare for epidemics. The epidemic also changed how the world thought about infectious disease. For decades, people in wealthy countries had treated tropical diseases as someone else's problem, something that happened over there and didn't concern them. The West African epidemic shattered that complacency. It proved that in our interconnected world, a disease outbreak anywhere is a threat everywhere. A child playing near a bat roost in Guinea could spark a chain of infections that eventually reached Dallas, Madrid, and New York. And indeed, the virus did reach those cities, in the bodies of infected healthcare workers and travelers. Each case in the developed world sparked panic out of proportion to the actual risk. When Ebola arrived in the United States, the media coverage was hysterical. 24-hour news cycles obsessed over every detail. Politicians demanded travel bans. Some called for quarantines of anyone who'd been to West Africa. Thomas Eric Duncan was a Liberian man who traveled to Dallas, Texas, in September 2014 to visit family. He'd been exposed to Ebola in Liberia but didn't know it when he boarded the plane. He developed symptoms after arriving and went to Texas Health Presbyterian Hospital. Initially, the hospital sent him home with antibiotics, missing the diagnosis despite him telling them he'd recently come from Liberia. He returned 2 days later by ambulance, critically ill. This time, he was isolated and tested. The result came back positive. Ebola had arrived in America, and the nation freaked out. Duncan died on October 8, 2014. He became the first person to die of Ebola on American soil. The media scrutiny was intense. Every detail of his case was dissected. Where he went, who he touched, what he ate. The apartment where he'd been staying was quarantined, the family inside confined for weeks. Hazmat teams decontaminated the building. 2 nurses who cared for Duncan became infected, Nina Pham and Amber Vinson. Their cases sparked even more panic. If trained healthcare workers in a modern American hospital could get infected, was anyone safe? Both nurses survived after treatment, but the fear lingered. The American response bordered on hysteria. Some schools banned students who'd traveled to Africa, even if they'd been nowhere near the affected countries. A teacher in Maine was forced to stay home after attending a conference in Dallas. Politicians called for military-enforced quarantines. Several states implemented their own quarantine rules that went beyond CDC recommendations. A doctor named Craig Spencer, who'd been treating Ebola patients in Guinea with Médecins Sans Frontières, returned to New York City. He felt fine, so he went about his normal life, riding the subway, going bowling. Then he developed a fever. He immediately self-quarantined and called authorities. He was rushed to Bellevue Hospital and isolated. The media went crazy. Every place he'd visited was examined. People who'd ridden the same subway cars panicked. Politicians demanded investigations. Dr. Spencer recovered. He'd infected exactly 0 people because he'd self-isolated the moment he felt symptomatic and because Ebola isn't contagious until symptoms appear. But the damage to public understanding was done. People believed Ebola was airborne, that it could spread through casual contact, that America was on the verge of an epidemic. None of this was true, but fear doesn't require truth. Feel the irony washing over you. Thousands dying in West Africa, and the world barely noticed. 4 cases in America, and it dominated the news for months. Think about what that says about whose lives we value. Let that uncomfortable truth settle into your consciousness as you drift towards sleep. The contrast between the American panic and the West African reality was stark. In Liberia, bodies lay in the streets waiting for collection. In America, one patient in isolation sparked a national crisis. In Sierra Leone, hospitals had run out of basic supplies. In America, hospitals had specialized isolation units with air filtration systems and unlimited resources. The disparity was obscene. Yet the American cases did serve a purpose. They forced the U.S. government to take the epidemic seriously. The CDC improved its Ebola response protocols. Hospitals across the country conducted training. Special treatment centers were designated and equipped. When future cases arrived, and they did, mostly healthcare workers who'd volunteered in West Africa and contracted the disease, the response was calmer and more professional. The epidemic ended in West Africa, but Ebola's story wasn't over. The virus still lurked in its reservoir hosts. It still spilled over occasionally. The difference was that now the world was ready. In May 2017, an outbreak began in the Likati Health Zone of the Democratic Republic of Congo. 9 cases, 4 deaths. The response was swift and effective. Within weeks, the outbreak was contained. Ring vaccination using the new Ebola vaccine played a crucial role. The world barely noticed. A few news articles, a WHO press release, and that was it. This was how Ebola responses were supposed to work. But the next outbreak would test everything the world had learned. Stay with me now. The story takes another dark turn, but this time there's a different ending. This time, humanity fights back with better tools, better knowledge, better preparation. The darkness isn't quite as deep. August 1st, 2018. North Kivu Province, Democratic Republic of Congo. A woman presented to a health clinic in Mangina with fever and bleeding. She died shortly after. 4 family members who'd cared for her fell ill. They died too. Tests confirmed Ebola, and the DRC Ministry of Health declared an outbreak. This wasn't just another remote village outbreak. North Kivu was a conflict zone. Armed groups controlled parts of the region. Violence flared regularly. Decades of war had left the population deeply suspicious of outsiders, especially foreigners claiming to help. The region had never experienced an Ebola outbreak before, so communities had no cultural memory of the disease. The response teams arrived with their protective suits, their vehicles, their foreign accents. They told people not to touch the sick, not to prepare bodies for burial, not to follow traditions that had sustained them for generations. Many communities rejected them. Some believed Ebola wasn't real, that it was a fabrication by the government or foreigners. Conspiracy theories spread. Ebola was created in a laboratory. The treatment centers were killing people. The vaccines were meant to sterilize Africans. This suspicion turned violent. Treatment centers were attacked. On February 24, 2019, armed men attacked the Ebola treatment center in Katwa, setting it on fire. Patients fled. Healthcare workers escaped with their lives but lost crucial equipment and supplies. Days later, another center in Butembo was attacked. A WHO epidemiologist was killed. The violence made containment nearly impossible. Contact tracers couldn't reach certain areas. Patients hid their symptoms. Communities concealed the sick and the dead. The virus spread unchecked in pockets where response teams couldn't operate. Yet despite these impossible challenges, the response continued. Healthcare workers showed up every day knowing they might be attacked. Vaccination teams persevered. By the time the outbreak ended on June 25, 2020, over 3,300 people had been infected and 2,280 had died. But over 300,000 people had been vaccinated, preventing countless additional cases. The North Kivu outbreak was the second largest Ebola outbreak in history, but it could have been much worse. The vaccine made the difference. Without it, the death toll would have been exponentially higher. The outbreak proved that even in the worst possible circumstances, active conflict, community resistance, targeted violence, Ebola could be fought and eventually defeated. Think about the courage that required. Imagine waking up every day knowing you might be attacked for trying to save lives. Imagine facing down assault rifles while holding a syringe. Imagine persisting despite the hatred, despite the fear, despite the very real danger. That's what the response teams did, day after day, for nearly 2 years. Let that bravery fill you with something close to hope. Yes, the world is full of horror. Yes, diseases like Ebola exist. But humans can be extraordinary in their dedication to helping others. Hold on to that as you sink deeper into rest. Make sure you've subscribed to Dreamless Timelines. These stories take time and research to craft properly. Your subscription helps make them possible. Hit the like button if you're appreciating this journey through Ebola's history. And leave a comment. I read every single one and use your feedback to improve future videos. The outbreak in North Kivu was still burning when another one ignited. On June 1, 2020, cases were detected in Equateur province in northwestern DRC, over 1,000 kilometers from North Kivu. Genetic analysis showed this was a completely separate spillover event, not related to the North Kivu outbreak. 2 simultaneous Ebola outbreaks in one country. It seemed impossibly cruel. The Equateur outbreak was smaller, 130 cases, 55 deaths, but it demonstrated something crucial. The response systems worked. The outbreak was identified quickly. Vaccines were deployed within days. Treatment centers were established. The outbreak ended on November 18, 2020, just over 5 months after it began. But even as that outbreak ended, another began. On February 7, 2021, a woman in Guec, Guinea, died after developing symptoms consistent with Ebola. Her husband, son, and several other family members fell ill. Tests confirmed Ebola. The nightmare was returning to Guinea, the same country where the devastating West African epidemic had begun 7 years earlier. This outbreak was small, 23 cases, 12 deaths, but it revealed something disturbing. Genetic sequencing of the virus showed it was nearly identical to strains from the 2014 to 2016 epidemic. The virus had been dormant somewhere for 5 years. The most likely explanation, it had persisted in a survivor, hiding in immune-privileged tissues, then reactivated or was transmitted sexually years later. This finding was terrifying. It meant that even years after an outbreak ended, the virus could resurface. Survivors could carry the virus for years without knowing it. The tail of an epidemic could be incredibly long, with flare-ups possible years after the last official case. Guinea's response was rapid and effective. They'd learned hard lessons from the previous epidemic. Vaccination campaigns began immediately. Contact tracing was aggressive. The outbreak was declared over on June 19, 2021, just 4 months after the first case. Simultaneously, another outbreak emerged in the DRC. On February 7, 2021, the exact same day as the Guinea case, a woman in North Kivu province died of Ebola. Over the next 3 months, 12 people were infected, 6 died. Again, the response was swift. Ring vaccination, isolation, treatment. The outbreak ended on May 3rd. Notice the pattern now. Ebola keeps emerging, but humans keep beating it back faster and more effectively each time. The virus hasn't changed, but we have. We've learned. We've adapted. We've become better at this terrible game. The outbreaks of 2020 and 2021 occurred during another global pandemic, COVID-19. Response teams had to fight Ebola while the world was consumed with coronavirus. Resources were stretched thin. International travel was restricted. Yet they managed both. Healthcare workers in the DRC and Guinea wore protective equipment for 2 different deadly viruses, often simultaneously. The resilience and dedication of these workers cannot be overstated. While the world worried about COVID, they were in the trenches fighting an even deadlier disease. While people in wealthy countries complained about mask mandates, these workers suited up in full body protection in 100-degree heat to treat Ebola patients. While armchair epidemiologists argued on social media, real epidemiologists were tracing contacts in conflict zones and vaccine-hesitant communities. Another outbreak struck Uganda in September 2022. This one was different. It was caused by Sudan Ebola virus, the strain first identified in 1976. The existing vaccine didn't protect against this strain. It was specific to Zaire Ebola virus. That meant old-school response methods: isolation, contact tracing, infection control, supportive treatment. The outbreak centered in Mubende and Kassanda districts. 164 cases, 77 deaths. The Ugandan government, battle-tested from previous outbreaks, implemented strict measures. Schools were closed. Movement was restricted. The outbreak was declared over on January 11, 2023, after 42 days with no new cases. The Uganda outbreak highlighted a continuing vulnerability. There's still no vaccine for Sudan Ebola virus. Researchers are working on it, but funding remains limited because the disease is relatively rare. It's the same old story. Market forces don't align with public health needs when the patients are poor Africans in remote areas. Feel the frustration of that. We have the technology. We have the knowledge. We could create vaccines for every Ebola strain. But we don't, because the cost-benefit analysis says it's not worth it. Let that injustice linger in your mind as you relax into the darkness behind your eyelids. As of today, in 2025, no active Ebola outbreak is occurring anywhere in the world. The virus is quiet, but it's still out there, in its bat reservoirs, in the forest, waiting for the next spillover event. And there will be a next time. That's certain. What's uncertain is whether we'll be ready. The total death toll from all Ebola outbreaks since 1976 exceeds 15,000 people. That's the official count. The real number is likely higher, accounting for unreported cases in remote areas, people who died before reaching medical care, deaths attributed to other causes in the early years before Ebola was well understood. 15,000 deaths. 15,000 people who woke up one morning feeling fine and within days or weeks were dead. 15,000 families destroyed. Thousands more survivors living with chronic pain, vision problems, neurological issues. Hundreds of thousands of people affected by lockdowns, quarantines, economic collapse, and social disruption. But it's not all darkness. We've learned so much. We understand how the virus spreads. We know the reservoir hosts. We have a highly effective vaccine for the most common strain. We have better treatment protocols that significantly improve survival rates. We have global surveillance systems that can detect outbreaks early. We have trained response teams ready to deploy anywhere in the world. The scientific knowledge gained from studying Ebola has applications beyond Ebola. The mRNA vaccine technology used for COVID-19 vaccines was informed partly by Ebola research. The rapid vaccine development for COVID drew on lessons from the accelerated Ebola vaccine trials. The protective equipment standards, the isolation protocols, the contact tracing methods, all refined through decades of Ebola responses, proved valuable during the COVID pandemic. Every outbreak teaches us something. The Yambuku outbreak taught us about nosocomial transmission. Kikwit taught us about urban spread. The West African epidemic taught us about the dangers of delayed response and the importance of community engagement. North Kivu taught us that vaccination works even in conflict zones. Guinea's 2021 outbreak taught us about long-term viral persistence. Each lesson was bought with blood, but the knowledge endures. The next outbreak will be fought with better tools, better strategies, better understanding. The death toll will be lower. The containment will be faster. Progress is incremental, but it's real. Allow yourself to feel something like peace with that. Yes, Ebola will return. But we're getting better at fighting it. The arc of medical history, like the arc of moral history, bends toward improvement. Slowly, painfully, but it bends. If you've made it this far in the journey, you're the kind of person who appreciates depth and complexity. You understand that history isn't just dates and numbers, it's human stories, tragic and triumphant. Subscribe to Dreamless Timelines for more content like this. Hit that like button to help the algorithm share this story with others who might appreciate it. Comment below with your thoughts, questions, or reactions. Your engagement literally keeps this channel alive. The story of Ebola is ultimately a story about us. About human vulnerability and human resilience. About the fragility of civilization and the strength of compassion. About fear and courage. About ignorance and knowledge. About death and survival. It's a story about a virus that evolution shaped into a nearly perfect killing machine. A filovirus that invades cells and turns them into factories producing billions of copies of itself. That triggers massive immune responses that cause more damage than the virus itself. That makes blood vessels leak and organs fail. That can kill 90% of those it infects. But it's also a story about nurses who kept showing up for work even after their colleagues started dying. About doctors who held the hands of patients they knew they couldn't save. About burial teams who handled infected corpses with dignity and care. About researchers who worked around the clock to develop vaccines and treatments. About survivors who overcame stigma to help others. About communities that adapted ancient traditions to stop transmission while maintaining cultural practices. Let me tell you about some of those people, because they deserve to be remembered. Dr. Jerry Brown, a Liberian physician who headed the obstetrics and gynecology department at John F. Kennedy Medical Center in Monrovia. When the epidemic hit, many doctors fled. Dr. Brown stayed. He delivered babies from mothers who might have Ebola. He operated on patients when no one else would. In September 2014, he contracted the virus. He died on September 28, leaving behind a wife and 4 children. Dr. Ameo Stella Adedivo, a Nigerian physician who treated Patrick Sawyer when he arrived in Lagos. She suspected Ebola before the diagnosis was confirmed. When Sawyer tried to leave the hospital against medical advice, she physically restrained him and refused to release him despite pressure from Liberian officials. Her actions prevented Sawyer from moving freely through Lagos and likely stopped a massive outbreak in Africa's largest city. She contracted Ebola from treating Sawyer and died on August 19, 2014. Nigeria erected a statue in her honor. She saved potentially millions of lives. Salome Karwa, a Liberian woman who survived Ebola, watched both her parents die from the disease, then dedicated herself to caring for other patients. She worked in an Ebola treatment center, using her immunity to comfort the sick without fear. She became internationally recognized, even appearing on Time magazine's cover as one of the Ebola fighters, named Person of the Year for 2014. In 2017, she died during childbirth from complications that might have been prevented if the healthcare system hadn't been so damaged by the epidemic. She was 28 years old. Fode Gala, a Liberian nurse who survived Ebola and then spent months caring for patients in treatment centers. He worked in the most dangerous sections, the areas where the sickest patients lay dying. He fed them, cleaned them, held their hands, prayed with them. He said in an interview, "I'm alive for a reason. Maybe that reason is to help others survive too." He became a symbol of hope in Liberia. Dr. Ian Crozier, an American physician who contracted Ebola while working in Sierra Leone. He was evacuated to Emory University Hospital, where he nearly died multiple times. He survived but months later developed severe eye inflammation. Doctors discovered Ebola virus persisting in his eye's aqueous humor, the clear fluid behind the cornea. It was the first confirmed case of the virus hiding in the eye. His left eye turned from blue to green as the inflammation damaged the iris. He eventually recovered his vision, but his case revealed new dangers of viral persistence. Nurse Nina Pham, who cared for Thomas Eric Duncan in Dallas. 26 years old, just starting her career. She followed protocols as she understood them but still became infected. She received experimental treatments, including a blood transfusion from Ebola survivor Dr. Kent Brantley. She recovered and later sued her hospital for inadequate training and equipment. The case settled out of court. She became a voice for healthcare worker safety. These weren't superheroes. They were ordinary people who chose to show up, to care, to fight. Many of them paid with their lives. Many more paid with trauma that will never fully heal. But they stopped Ebola from spreading even further. They saved lives. They deserve to be remembered as we drift toward sleep, their courage a lullaby against the darkness. Breathe slowly now, in and out. Let the weight of these stories rest gently on your consciousness. Feel the presence of all those who fought and all those who fell. They're part of the tapestry of human history now, woven into the story of how we confronted nature's cruelty with our own stubborn compassion. The research continues. Scientists are still trying to understand exactly how Ebola persists in survivors. They're developing vaccines for the other strains. They're creating better treatments beyond just supportive care. Monoclonal antibody cocktails have shown promise. Remdesivir, an antiviral drug, has shown some effectiveness. The survival rate keeps inching upward. Researchers are also studying the bat reservoirs more intensively. They're trying to map the geographic range of the 3 main fruit bat species that carry Ebola. They're examining bat migration patterns, trying to predict where spillover events are most likely. Some propose culling bat populations near human settlements, but others argue this would be ecologically devastating and might not even work. The bats serve crucial roles in forest ecosystems, pollinating plants and dispersing seeds. The fundamental challenge is that humans and wildlife share the same space more than ever before. Deforestation pushes deeper into previously untouched areas. Mining operations penetrate remote forests. Population pressure forces people into marginal lands. Climate change alters animal migration patterns and habitat ranges. All of these factors increase the likelihood of spillover events. Ebola isn't the only disease lurking in the forest. Lassa fever, Marburg virus, Crimean Congo hemorrhagic fever, Nipah virus, dozens of others we probably haven't discovered yet. Each one a potential pandemic waiting for the right circumstances. The World Health Organization maintains a list of priority diseases, pathogens that pose the greatest public health risk. Ebola is on that list, but so are 8 others, plus Disease X, a placeholder for the unknown pathogen that will cause the next pandemic. We're living in what some scientists call the pandemic era. The combination of population density, global travel, environmental destruction, and livestock intensification creates perfect conditions for diseases to jump from animals to humans and then spread globally. Ebola is just one example. COVID-19 is another. The next one is already out there, waiting. But here's the thing that should help you sleep tonight. We're also living in the era of unprecedented scientific capability. We can sequence a virus's genome in hours. We can develop vaccines in months instead of decades. We can track disease spread in real time using smartphones and satellite data. We can manufacture treatments at scale and deploy them anywhere in the world within days. The question isn't whether we have the tools to fight the next pandemic. We do. The question is whether we have the political will, the funding, and the global cooperation to use those tools effectively. Whether we'll respond to an outbreak in Africa with the same urgency we'd respond to one in New York or London. Whether we'll remember the lessons Ebola taught us or whether we'll have to learn them again the hard way. Let those questions float through your mind like clouds across a darkening sky. You don't need to answer them. Just acknowledge them and let them drift away. The world's problems are not yours to solve tonight. Tonight, you rest. You listen. You learn. That's enough. Let's talk about what it's actually like to have Ebola. Not the statistics or the science, but the human experience. Because understanding the disease means understanding what it does to a person. It starts innocuously enough. A fever. Maybe you think it's malaria. Maybe you think it's the flu. You feel tired. Your head aches. Your muscles are sore. These symptoms are so common in tropical climates that most people don't worry too much at first. They rest. Drink water. Maybe take some traditional medicine or anti-malarials. But over the next few days, the fever doesn't break. it gets worse. You start to feel a deep, bone-deep exhaustion unlike anything you've experienced before. Your joints hurt. Your chest aches. You can't keep food down. The nausea is overwhelming. Then comes the vomiting and diarrhea, relentless and severe. You're losing fluids faster than you can replace them. Your mouth becomes dry. Your skin loses its elasticity. Dehydration sets in. Around day 5 or 6, the hemorrhaging might begin. This is what makes Ebola so visually terrifying. You might notice blood in your vomit or stool. Your gums might bleed when you brush your teeth. If you've had injections, those sites might start seeping blood. Your eyes become bloodshot, the whites turning red. In severe cases, you might bleed from your nose, your ears, even your eyes, though this dramatic bleeding is actually less common than movies would have you believe. What's happening inside your body is catastrophic. The virus has invaded your cells, particularly the cells of your immune system and the cells lining your blood vessels. It's replicating at an exponential rate. Your immune system is going haywire, releasing massive amounts of inflammatory chemicals called cytokines. This cytokine storm causes more damage than the virus itself in many cases. Your blood vessels become leaky. Fluid seeps out into your tissues, causing swelling and dropping your blood pressure. Your organs aren't getting enough oxygen. Your kidneys might start to fail. Your liver is struggling. Your heart is racing, trying to compensate for the falling blood pressure. Your brain is foggy from the fever and the lack of oxygen. If you make it to a treatment center, you'll be isolated. You'll wear a hospital gown or maybe just lie on a plastic sheet because everything you touch becomes contaminated. Healthcare workers will approach you dressed like astronauts. Full body suits, goggles, gloves, masks. You can't see their faces clearly. You can't hear them well through all the protective equipment. It's terrifying and isolating. They'll start in 4, pumping fluids into your veins to combat the dehydration. This is crucial. Many Ebola patients who survive do so because they receive aggressive rehydration. They'll give you pain medication because the muscle and joint pain is excruciating. They'll monitor your vital signs constantly. They might give you antibiotics to prevent secondary infections since your immune system is compromised. If you're lucky enough to be in a facility with advanced treatments, you might receive monoclonal antibodies, laboratory-created proteins that help your immune system fight the virus. You might get antiviral medications. You might receive blood transfusions if your bleeding is severe. But in most outbreaks, in most places, the treatment is just supportive care. Keep you hydrated. Manage your pain. Treat complications. Hope your immune system wins the battle. The turning point comes around day 7 to 10. Either your immune system gets the upper hand and you start to improve, or the virus overwhelms you and you die. There's often not much middle ground. Your fever might break. Your energy might return slowly. Or you slip into shock, your organs shutting down one by one, and you fade away. Survivors describe the recovery as brutally slow. You're weak as a newborn. You've lost massive amounts of weight. Your muscles have atrophied from days of immobility. You might have neurological damage causing tremors or difficulty concentrating. Your vision might be blurry. You face months of rehabilitation, slowly rebuilding your strength. And then there's the psychological trauma. You've watched other patients die around you. You've been isolated from your family for weeks. You carry the guilt of survival when others didn't make it. You know that some people in your community will fear and stigmatize you. You might have lost family members to the same outbreak. The mental scars often run deeper than the physical ones. Imagine that journey. Really put yourself in those moments. The fear, the pain, the isolation, the uncertainty. Let it make you grateful for your health, for your safety, for the simple act of lying comfortably in bed without a deadly virus destroying you from within. Subscribe to Dreamless Timelines if you haven't already. This kind of detailed historical storytelling takes immense research and effort. Your subscription tells me you value this work. Like the video if you're finding it informative and engaging. Comment with your thoughts. I genuinely love reading them. Your engagement helps this channel reach more people who appreciate deep dives into history's darkest moments. The economic impact of Ebola outbreaks extends far beyond the immediate health costs. Let's look at what happened in West Africa during the 2014 to 2016 epidemic. Agriculture collapsed. Farmers couldn't tend their fields because of quarantines, fear, or illness. Rice production in Liberia dropped by more than 40%. Cocoa production in Sierra Leone fell sharply. When planting seasons were missed, it affected food security for years afterward. Fields that weren't planted in 2014 didn't yield crops in 2015, creating cascading food shortages. Markets shut down. People were afraid to congregate in crowded spaces where disease might spread. The bustling markets that are the lifeblood of West African commerce became ghost towns. Vendors lost their livelihoods. Supply chains broke down. Prices for basic goods skyrocketed as scarcity set in. International trade ground to a halt. Ships stopped docking in West African ports. Airlines canceled flights. The few flights that continued saw their passenger loads drop to near zero. Business travelers stayed away. Tourists canceled trips. The isolation was economic as well as epidemiological. Mining operations suspended or reduced activities. Guinea has significant iron ore and bauxite deposits. Liberia has iron ore and diamonds. Sierra Leone has diamonds, titanium, and bauxite. These mining operations employ thousands and generate crucial foreign exchange. When they shut down or scaled back, the economic ripple effects were enormous. Foreign investment evaporated. Who wants to invest in a country gripped by an epidemic? Development projects stalled. Construction stopped. The economic development that these countries desperately needed was postponed indefinitely. The World Bank estimated that the epidemic cost the three most affected countries over $2 billion in GDP in 2015 alone. Some estimates for the total economic cost over several years run as high as $53 billion when you include indirect effects like lost productivity, reduced investment, and long-term economic scarring. But here's what statistics don't capture: the individual human cost. The market vendor who lost her entire inventory when markets closed and had to start from scratch afterward. The taxi driver who couldn't work for months and fell into debt. The hotel worker whose business closed and never reopened. The farmer who missed a planting season and couldn't feed his family. The seamstress whose customers stopped coming and who had to sell her sewing machine to buy food. Multiply those individual tragedies by millions, and you start to understand the true economic devastation. Ebola didn't just kill 15,000 people. It impoverished millions more. It set back development by years or decades. It created a lost generation of children whose education was interrupted or abandoned entirely. Schools closed for months. In Liberia, schools shut down in July 2014 and didn't reopen until February 2015. 7 months of lost education. Some students never returned. They'd started working to help their families survive and couldn't afford to give up that income. Girls especially dropped out at high rates, forced into early marriage or labor. The long-term effects of this educational disruption will echo for decades. A generation of students who missed months or years of school. Future doctors, engineers, teachers, leaders whose potential was stunted by an epidemic. The human capital lost is incalculable. Healthcare systems that were already fragile before the epidemic were shattered by it. Hospitals and clinics closed. Healthcare workers died or fled. Equipment was destroyed or contaminated. Vaccine cold chains broke down. Routine immunization programs stopped. As a result, measles, polio, and other preventable diseases resurged. Some researchers estimate that the disruption to healthcare services during the Ebola epidemic caused as many deaths from other diseases as Ebola itself caused directly. Pregnant women stopped going to clinics for prenatal care and delivery. Maternal mortality spiked. Babies died who wouldn't have died in normal times. People with HIV stopped getting their antiretroviral medications. Tuberculosis patients interrupted their treatment, leading to drug resistance. Malaria treatment and prevention programs faltered. The full death toll of the Ebola epidemic includes not just the 11,000 who died directly from the virus, but the many thousands more who died from other causes because the healthcare system collapsed. Feel the weight of those compounding tragedies. One crisis creating another. Systems breaking down. Suffering multiplying. Let it remind you how interconnected everything is, how fragile our social structures are, how quickly order can dissolve into chaos. But now, let's talk about hope. Because amidst all this darkness, there were genuine triumphs and reasons for optimism. The vaccine worked. That bears repeating because it's genuinely miraculous. A 100% effective vaccine against one of the deadliest diseases known to humanity. Since its deployment, tens of thousands of people have been vaccinated in outbreak settings. The vaccine has prevented countless cases and saved thousands of lives. It's now being used prophylactically for healthcare workers and contacts of cases in every outbreak. Treatment has improved dramatically. The monoclonal antibody cocktails developed during and after the West African epidemic increased survival rates significantly. In clinical trials, some treatments reduced mortality to around 30%. Still terrible, but much better than the 70 to 90% seen in untreated cases. Two specific treatments deserve mention. MAB-114 is a monoclonal antibody isolated from a survivor of the 1995 Kikwit outbreak. Scientists extracted it from the blood of a survivor, identifying the specific antibody that had helped them overcome the infection. This antibody was then manufactured in the lab and tested. It works by binding to the Ebola virus glycoprotein, preventing the virus from entering cells. REGN-EB3 is a cocktail of 3 monoclonal antibodies developed by Regeneron Pharmaceuticals. In a randomized control trial during the North Kivu outbreak, it showed about 70% survival rates, significantly better than the standard of care at the time. These treatments represent a fundamental shift. Ebola is no longer a death sentence. If you can get to a treatment center early and receive these medications, your chances of survival are decent. Not guaranteed, but decent. That's a hell of a lot better than the near-certain death that characterized earlier outbreaks. Global health security has improved. The Joint External Evaluation is a voluntary process where countries assess their epidemic preparedness across 19 technical areas. Over 100 countries have conducted these evaluations since 2016. They identify gaps and prioritize improvements. It's not perfect, but it's progress. The Coalition for Epidemic Preparedness Innovations, or CEPI, was launched in 2017 specifically to accelerate vaccine development for emerging infectious diseases. It's funded by governments and private foundations. Its mission is to develop vaccines before outbreaks occur, not scramble to create them during emergencies. CEPI has funded research on multiple Ebola vaccine candidates, including vaccines for the Sudan and Bundibugyo strains that currently lack protection. Early warning systems have improved. Surveillance networks in Africa are stronger than they were a decade ago. Disease reporting is faster. Laboratory capacity has increased. Many countries can now confirm Ebola cases within their own borders instead of sending samples abroad and waiting days or weeks for results. The Global Outbreak Alert and Response Network coordinates responses more effectively. When an outbreak occurs, teams can deploy within hours instead of days. They bring standardized equipment and protocols. They've trained thousands of local healthcare workers in infection prevention and control. The institutional memory and capacity that exist now simply weren't there before the West African epidemic. Community engagement strategies have evolved. Responders learned the hard way that you can't just arrive in a community, tell people to abandon their traditions, and expect cooperation. Now the approach is more collaborative. Anthropologists work with response teams to understand local beliefs and practices. Solutions are developed with communities, not imposed upon them. Safe burial practices, for example, were redesigned to honor cultural traditions while preventing transmission. Instead of banning traditional burials entirely, teams worked with communities to modify them. Bodies are washed by trained burial teams wearing protective equipment, but family members can observe. Traditional prayers and rituals are incorporated. The body is wrapped in a way that respects local customs while preventing contact. It's a compromise that acknowledges both the spiritual needs of communities and the epidemiological realities of the disease. Religious leaders became crucial allies in outbreak responses. Initially, they were sometimes part of the problem, holding prayer services that became super-spreader events, or promoting beliefs that Ebola was God's punishment. But when engaged respectfully, many became powerful advocates for safe practices. Imams and pastors spread public health messages from pulpits. They helped reduce stigma against survivors. They facilitated safe burials. Their moral authority reached people that government messages couldn't. Survivor networks have organized and become advocates. In Liberia, Sierra Leone, and Guinea, Ebola survivor associations provide mutual support, combat stigma, and serve as voices for their communities. Some survivors have become community health workers, using their immunity and experience to care for patients in subsequent outbreaks. They're living proof that Ebola can be survived, which provides hope to current patients. Let yourself feel that hope. Real, tangible progress. Lives saved. Systems improved. Knowledge gained. The fight against Ebola isn't won, but we're winning more battles than we're losing. That's worth celebrating quietly as you drift toward sleep. Technology has revolutionized outbreak response in ways that would have seemed like science fiction during the first outbreaks. Mobile phones are everywhere now, even in remote African villages. This connectivity enables real-time disease surveillance. Healthcare workers can report cases instantly via text message or smartphone app. Contact tracers can enter data into digital systems that automatically map transmission chains. GIS mapping and satellite imagery help track disease spread. Researchers can overlay case locations with population density, road networks, and environmental features to predict where the virus might go next. Helicopters and drones deliver supplies to remote areas, bypassing impassable roads. Rapid diagnostic tests have improved dramatically. The early outbreaks required sending blood samples to distant laboratories and waiting days for results. Now, portable PCR machines can confirm Ebola within hours at the field level. Some experimental tests can provide results in 15 minutes, though these aren't yet widely deployed. Telemedicine allows experts thousands of miles away to consult on difficult cases. A doctor in a rural Congolese clinic can video conference with Ebola specialists in Atlanta or Geneva, getting real-time advice on patient management. This democratizes expertise in ways that save lives. 3D printing has enabled on-demand production of equipment. During the North Kivu outbreak, organizations used 3D printers to create custom equipment pieces, from protective gear components to medical device parts, right in the field instead of waiting for shipments from abroad. Social media, despite its problems, has helped with health education. Public health messages can spread rapidly through WhatsApp, Facebook, and local platforms. Misinformation spreads too, of course, but the ability to reach large populations quickly with accurate information is powerful. Genomic sequencing has become routine. Every outbreak now involves extensive sequencing of viral samples. This tells us where the virus came from, how it's mutating, whether cases are linked to each other or represent separate spillover events. During the North Kivu outbreak, sequencing revealed multiple introductions from the bat reservoir, not just one initial spillover. This information shaped response strategies. The data generated by modern outbreaks is staggering. Thousands of genome sequences, millions of contact tracing records, detailed clinical data on thousands of patients, treatment outcomes, vaccine effectiveness. All of this information feeds into better models, better predictions, better responses for the next outbreak. Machine learning algorithms analyze this data to identify patterns humans might miss. They can predict which areas are at highest risk for outbreaks based on environmental factors, animal populations, and human behavior. They can forecast how an outbreak might spread under different intervention scenarios. They can optimize resource allocation, determining where to place treatment centers or deploy vaccination teams for maximum effect. Imagine the future that's emerging. A future where diseases are detected before they spread widely, where treatments are deployed before people die, where vaccines are ready before outbreaks begin. We're not there yet, but we're moving in that direction. Let that vision of a healthier future lull you deeper into rest. Before you drift too far, remember to engage with this content. Subscribe to Dreamless Timelines. Like this video. Leave a comment about what surprised you most in this Ebola history. Your engagement literally determines whether I can continue creating content like this. It's not just appreciated, it's essential. Let's talk about some of the science that's still being unraveled. Despite decades of research, there's still so much we don't know about Ebola. The reservoir question isn't fully solved. Yes, fruit bats are the prime suspects. But Ebola virus has never been isolated from a living bat in the wild. Scientists have found viral RNA in bats. They've found antibodies in bats. But they haven't found the actual infectious virus. Some researchers wonder if bats are the true reservoir or if they're just one link in a more complex chain. Alternative theories exist. Maybe the virus cycles between multiple species. Maybe there's an invertebrate host we haven't identified. Maybe the virus can persist in soil or water under certain conditions. The fact that outbreaks sometimes occur in locations with no obvious exposure to bats suggests we're missing part of the picture. Why does the virus cause such severe disease in humans and other primates but apparently not in bats? This is a fascinating evolutionary question. One theory is that bats co-evolved with filoviruses over millions of years, developing immune systems that can control the infection without eliminating it. Primates encountered these viruses more recently in evolutionary time and haven't evolved the same defenses. Bat immune systems are unique. They have a dampened inflammatory response compared to other mammals. This might allow them to carry viruses without the cytokine storm that kills primates. Some bat species have extra copies of genes involved in antiviral defense. Understanding these differences could lead to new treatment strategies for humans. Why do different Ebola strains have such different mortality rates? Zaire Ebola virus kills up to 90% of untreated patients. Sudan Ebola virus kills around 50%. Bundibugyo Ebola virus kills around 40%. Thai forest Ebola virus has only caused one known human case, which the patient survived. These viruses are genetically similar but clinically distinct. What genetic changes account for the differences in lethality? Researchers have identified some virulence factors, specific viral proteins that determine how deadly the virus is. The VP35 protein suppresses the interferon response, the body's first-line antiviral defense. Viruses with more effective VP35 proteins are generally more lethal. The glycoprotein determines which cells the virus can infect. Small changes in these proteins can have big effects on how the disease progresses. Why do some people survive without treatment while others die despite the best medical care? Host genetics likely play a role. Some people might have genetic variations that make their immune systems more effective at fighting Ebola. Researchers have studied survivors to identify these protective genes, but it's complex. No single gene determines survival. It's a combination of many factors: genetics, age, general health, viral load at infection, timing of treatment, and likely some luck. How long can the virus persist in survivors? We know it can hide in the eyes, testes, and central nervous system for months or years. But what's the maximum duration? Are there people walking around with dormant Ebola in their bodies from outbreaks decades ago? The Guinea 2021 outbreak suggested the virus persisted for at least 5 years in someone. Could it persist even longer? What triggers reactivation? Most survivors clear the virus completely and never have problems. But occasionally, the virus seems to wake up. What causes this? Immune suppression? Stress? Random chance? Understanding this could help us prevent future flare-ups. Can Ebola become endemic in human populations? So far, it always burns out or gets contained. But theoretically, if the virus evolved to be less lethal and more transmissible, it could establish itself permanently in humans. Some researchers worry about this possibility, especially as climate change and habitat destruction increase human-wildlife contact. Could Ebola evolve to become airborne? This is the nightmare scenario that keeps virologists up at night. Currently, Ebola spreads through direct contact with bodily fluids. But viruses mutate. Could a mutation arise that allows respiratory transmission? Most experts say it's unlikely. The virus would have to change fundamentally in ways that might reduce its ability to replicate. But unlikely isn't impossible. During the West African epidemic, there was evidence of Ebola adapting to human hosts. The virus acquired mutations that made it replicate more efficiently in human cells. Fortunately, none of these mutations changed the transmission route, but it demonstrated that the virus can and does evolve during large outbreaks. Let these questions wash over you. All the unknowns, all the uncertainties. Science is a process of turning unknowns into knowns, slowly, painstakingly. We're further along that path than we were 50 years ago, but there's still so far to go. That's okay. That's how knowledge works. Incremental, patient, persistent. The ethical questions raised by Ebola outbreaks are profound and troubling. Let's confront them honestly. Should experimental treatments be used during outbreaks? During the West African epidemic, several patients received ZMapp and other experimental drugs that hadn't been fully tested. Some survived. But was it the drugs, or would they have survived anyway? We'll never know for certain because there weren't proper controlled trials. The WHO convened ethics panels that concluded it was ethical to use unproven interventions during the crisis, given the high mortality rate and lack of alternatives. But this raised questions. Who gets the experimental treatments? The first patients, healthcare workers, foreigners, children, pregnant women? When supplies are limited, who decides who lives and who dies? Dr. Kent Brantley received ZMapp. So did a handful of other Westerners. But there wasn't enough for the thousands of Africans dying in treatment centers. That disparity is morally uncomfortable. Yes, the drugs were experimental and might not have worked. Yes, manufacturing capacity was limited. But still, the optics of white foreigners getting special treatments while black Africans died with only supportive care reinforced centuries of colonial exploitation and medical racism. Some argued that experimental drugs should have been used more widely in Africa, even without proper trials. Others argued that using untested drugs on desperate African patients without rigorous ethical oversight would have been exploitative, reminiscent of the Tuskegee syphilis study and other medical atrocities. There's no easy answer. Should we quarantine entire communities? The cordons sanitaires established during outbreaks prevented transmission but caused immense hardship. Families were separated. Food supplies ran low. People lost livelihoods. Some tried to escape and were turned back at gunpoint. From a pure epidemic control standpoint, quarantines work. From a human rights standpoint, they're deeply problematic. The American quarantines of healthcare workers returning from West Africa were particularly controversial. Some states implemented mandatory 21-day quarantines for anyone who'd been in affected countries, regardless of whether they showed symptoms or had known exposures. Public health experts argued this was counterproductive. It discouraged healthcare workers from volunteering to fight the epidemic. But politicians felt pressure to do something to protect their constituents. Casey Hickox, a nurse who'd treated Ebola patients in Sierra Leone, was quarantined upon her return to New Jersey despite having no symptoms and testing negative for the virus. She was held in a tent outside a hospital for days. She called it inhumane and unscientific. She was eventually released and defied Maine's quarantine order, arguing that asymptomatic people don't transmit Ebola. She was right on the science, but the public reaction was harsh. Should traditional burial practices be banned? From an epidemiological perspective, yes, washing and touching corpses spreads the virus. But from a cultural perspective, these rituals are deeply meaningful, providing spiritual closure and honoring the dead. Banning them entirely was insensitive and counterproductive in many cases, driving practices underground where they couldn't be made safer. The compromise approach, modified safe burials, worked better but required immense effort to implement. It required training burial teams, gaining community trust, and adapting to countless local variations in tradition. It would have been easier to just ban everything. But easier isn't always right. Should we compensate survivors for participating in research? Researchers have collected thousands of samples from Ebola survivors: blood, semen, tears, breast milk, cerebrospinal fluid, to study viral persistence and immunity. This research is valuable, leading to better treatments and vaccines. But survivors often received no compensation beyond basic medical care. They contributed to science that will generate profits for pharmaceutical companies, but they don't share in those profits. Is that fair? Some argue that paying research participants in poor countries is exploitative because desperate people might consent to dangerous procedures for money. Others argue that not paying them is exploitative because you're extracting value without compensation. Again, no easy answer. Should wealthy countries invest billions in diseases that primarily affect poor Africans? From a pure market perspective, no, there's no return on investment. From a humanitarian perspective, absolutely. From a self-interest perspective, maybe, today's African disease could be tomorrow's global pandemic. The fact that we're even debating this reveals uncomfortable truths about global priorities. COVID-19 provided a stark contrast. When a disease threatened wealthy countries directly, money materialized instantly. Operation Warp Speed in the United States alone spent $18 billion on COVID vaccine development and manufacturing. For Ebola, which killed thousands of Africans over 40 years, funding was a constant struggle. The message was clear: some lives are valued more than others. Sit with that discomfort. Don't try to resolve it or justify it. Just acknowledge it. The world is unjust. Medical resources are distributed inequitably. People die because of where they were born. These truths should disturb you, even as you relax into sleep. Especially as you relax into sleep. Let me tell you about what it was like inside the Ebola treatment centers. These descriptions come from healthcare workers who served there. The treatment centers, or ETCs, were divided into zones based on contamination risk. The green zone was safe. This was where staff changed into protective equipment, where supplies were stored, where administrative work happened. The yellow zone was potentially contaminated, areas where you might encounter virus but weren't actively treating patients. The red zone was hot, the wards where patients stayed, where every surface was assumed to be contaminated. Entering the red zone required elaborate preparation. First, you put on scrubs. Then a waterproof coverall. Then a plastic apron over that. Gloves, taped to the coverall sleeves so there were no gaps. Rubber boots, also taped. A hood covering your head and neck. Goggles. A face mask or respirator. Another pair of gloves over the first pair. In the heat of tropical Africa, this ensemble was suffocating. Before entering, a buddy checked your suit for any tears or gaps. If they found any, you changed. One tiny opening could kill you. You wrote your name in marker on your suit because once everyone was dressed, you couldn't tell who was who. Inside the red zone, the heat was unbearable. Within minutes, you were drenched in sweat. Your goggles fogged up. Your breathing became labored. You could work for maybe an hour before heat exhaustion forced you out. Some workers lost 10 or 15 pounds during their deployments just from sweating. The wards were filled with the sounds of suffering, moaning, crying, the wet sounds of vomiting and diarrhea, the beeping of monitors, the calls for help that you sometimes couldn't respond to quickly enough because you were already helping someone else or needed to maintain infection control protocols. The smell was overwhelming. Bleach was everywhere. Floors, walls, equipment, everything was constantly doused in chlorine solution. But underneath the bleach was the smell of illness. Vomit, diarrhea, blood, sweat, fear. You could taste it through your mask. Patients lay on waterproof mattresses covered with plastic sheets. Many were too weak to move. They urinated and defecated where they lay. Healthcare workers had to clean them, all while maintaining full protective equipment, in stifling heat, knowing that one wrong move could mean infection. Starting in 4 on a severely dehydrated patient while wearing 2 pairs of gloves in a suit that restricts movement is incredibly difficult. Your hands don't have normal dexterity. Your vision is limited by fogged goggles. The patient's veins are collapsed from dehydration. You're exhausted and overheated. But you have to succeed because that 4 might be the difference between life and death. The worst part, many workers said, was the isolation patients experienced. They were surrounded by people dressed like aliens. They couldn't see faces or read expressions. Touch, which is so important for comfort, was limited. You couldn't hold a patient's hand without gloves and barriers between you. You couldn't hug them or stroke their hair or offer normal human comfort. Children were especially heartbreaking. Imagine being a sick, terrified child, separated from your parents, in a strange place, with people in frightening suits who poke you with needles and speak in muffled voices you can barely understand. Some children were orphans, their parents had died of Ebola, and now they were sick too. Who comforts a dying child when touch itself is dangerous? Some healthcare workers sang to patients. Sang hymns or traditional songs. The patients couldn't see smiles through the masks, but they could hear kindness in a voice. Some workers danced a little, trying to lift spirits. Anything to provide comfort in the most uncomfortable circumstances imaginable. When patients died, workers wrapped the bodies in leak-proof bags and sprayed them with disinfectant. The bodies were removed by specially trained teams and taken for burial. There were so many deaths that it became routine, which was itself traumatic. How do you process watching people die day after day, sometimes multiple people in a single shift? Exiting the red zone was just as elaborate as entering. You moved to the doffing area, where a colleague supervised your removal of protective equipment. There was a specific order to follow. First outer gloves, into a bin of chlorine solution. Then apron, carefully rolled so the contaminated side was contained. Then goggles, into disinfectant. Then hood. Then coverall, carefully pulled off without touching the outside. Then boots. Then inner gloves. Each item into designated bins. Between each step, you cleaned your hands with chlorine solution or hand sanitizer. One mistake, one touch of your face with a contaminated glove, could be fatal. After doffing, you showered thoroughly, scrubbing every inch of skin. Then you rested, rehydrated, and prepared to do it again the next shift. Day after day, week after week. The psychological toll was immense. Many workers developed PTSD, nightmares, anxiety, depression, survivor's guilt when they stayed healthy while patients died. Some quit and went home. Others stayed until the outbreak ended, driven by a sense of duty or calling that overrode their fear. Feel the enormity of that sacrifice. These weren't soldiers on a battlefield. They were nurses and doctors and sanitation workers who chose to walk into hell to help others. They didn't have to. They could have stayed safe. But they went anyway. Let their courage inspire you even as it humbles you. Take a moment to subscribe to Dreamless Timelines if this journey through Ebola's history is meaningful to you. Hit that like button. Drop a comment sharing what you're thinking or feeling. These simple actions take seconds, but they make a real difference in whether content like this can continue to exist. Now let's talk about the conspiracy theories and misinformation that plagued every Ebola outbreak. Understanding these is crucial because they often did as much damage as the virus itself. In many outbreak areas, rumors spread that Ebola wasn't real, that it was a fabrication by the government to get foreign aid money, that it was created in a laboratory as a bioweapon, that it was being spread deliberately to kill certain ethnic groups or reduce population. These weren't fringe beliefs. Significant percentages of affected populations believed them. In Sierra Leone during the 2014 epidemic, surveys showed up to 25% of people in some areas didn't believe Ebola was real. In parts of the Democratic Republic of Congo during the North Kivu outbreak, trust in response teams was so low that many communities actively resisted interventions. Why did people believe these things? Multiple reasons. Historical trauma plays a role. Many African countries experienced brutal colonial exploitation, often involving medical experiments and atrocities. The Tuskegee syphilis study in the United States, where black men were deliberately left untreated to study the disease's progression, wasn't unique. Similar horrors occurred in colonial Africa. Lack of trust in governments was another factor. In countries with histories of corrupt, incompetent, or authoritarian governments, people have good reasons to be skeptical of official narratives. When the government suddenly cares deeply about your health despite ignoring you for years, suspicion is rational. The invisible nature of viruses fed doubts. You can't see Ebola. People got sick and died, but from what? Traditional beliefs attributed illness to witchcraft, curses, or spiritual causes. The germ theory of disease, which seems obvious to those raised with Western education, isn't intuitive. Why would an invisible particle make you sick? The response itself seemed suspicious. Foreigners in spacesuits showing up in your village, taking away sick people who then died, demanding you abandon traditions, restricting movement. It looked like an invasion, not a rescue. Especially when those same foreigners' countries had historically exploited your continent for resources and labor. Treatment centers became particular targets of suspicion. People went in but often didn't come out. Families weren't allowed to visit. Bodies were taken away and buried without traditional rites. From the outside, it looked like the centers were where people went to die, not to be healed. Some believed the centers were killing people to harvest their organs or for ritual purposes. This belief led to tragic consequences. Patients fled from centers, or families hid sick relatives to prevent them from being taken away. This meant people died at home, spreading the virus to caregivers and family members. It meant outbreaks continued longer than they needed to. In Monrovia in August 2014, a mob attacked an Ebola isolation center, freeing patients and looting supplies. The attackers believed the center was making people sick, not treating them. They took contaminated mattresses and bedding, which undoubtedly spread the virus further. The incident was driven by fear, anger, and misinformation. Social media amplified misinformation. WhatsApp groups spread rumors at viral speed. False cures circulated widely. Drinking salt water, eating bitter cola, bathing in hot water with salt. None of these worked, but desperate people tried anything. Some of these false cures were harmless. Others were dangerous. There were reports of people drinking bleach or poisoning themselves with harmful substances they believed would protect them from Ebola. Some religious leaders claimed Ebola was God's punishment for sin. Others said prayer alone could cure it, discouraging people from seeking medical treatment. Faith healers claimed they could cast out the Ebola demon. These beliefs weren't universal. Many religious leaders actively supported the response and helped educate communities, but the harmful ones caused real damage. Political misinformation also spread. Opposition leaders in some countries claimed the government was exaggerating the epidemic for political gain. Some claimed there was no Ebola, just the government trying to cancel elections or impose martial law. These claims undermined response efforts and reduced compliance with safety measures. Combating misinformation required extensive community engagement. Response teams employed anthropologists and social scientists to understand local beliefs and develop culturally appropriate messaging. They worked with trusted community members, traditional chiefs, religious leaders, teachers, respected elders, to spread accurate information. Radio programs became crucial. In areas with limited literacy and internet access, radio reaches almost everyone. Programs featured survivors sharing their experiences, doctors explaining the disease, and religious leaders endorsing safety measures. Call-in shows allowed people to ask questions and voice concerns. Community meetings, held outdoors with proper distancing, allowed face-to-face dialogue. Response teams listened to concerns without dismissing them. They acknowledged historical reasons for mistrust. They involved community members in designing solutions. This approach was slower than just imposing rules, but it was more effective and more respectful. Survivors became powerful communicators. When someone from your own village who had Ebola and recovered told you the disease was real and treatment helped, that carried more weight than any foreigner in a suit could convey. Survivor networks organized community education sessions, demonstrating that Ebola was survivable and that treatment centers helped rather than harmed. Despite these efforts, mistrust persisted in some areas throughout outbreaks. The North Kivu outbreak struggled with community acceptance for its entire duration. Attacks on treatment centers continued sporadically. Some areas remained essentially unreachable. This prolonged the outbreak significantly. Consider how difficult it must be to convince someone their worldview is wrong when that worldview is rooted in lived experience of exploitation and betrayal. Trust is hard to build and easy to destroy. The legacy of colonialism and medical racism creates justified skepticism that makes disease control harder. There are no villains in this part of the story, just tragic misunderstandings and historical wounds that haven't healed. Let's shift to something more hopeful: the remarkable stories of communities that successfully protected themselves through traditional systems adapted for the epidemic. In some Liberian villages, communities organized their own quarantines before the government imposed them. Village leaders held meetings and collectively decided to restrict entry and exit. They stationed volunteers at paths leading into the village to check anyone coming in for symptoms. They established local isolation areas for anyone who fell ill. They created community support systems to ensure quarantined families had food and supplies. These community-led initiatives worked because they had local buy-in. People followed rules they'd helped create more readily than those imposed from outside. The traditional authority structures, chiefs, elders, councils, that had governed these communities for generations were mobilized for epidemic control. In Sierra Leone, secret societies traditionally responsible for initiation rites adapted their practices. The Poro Society for men and Bondo Society for women are powerful cultural institutions. Initially, some of their practices, which involve seclusion, bodily modifications, and close physical contact, were vectors for transmission. But society leaders, once engaged respectfully, became allies. They modified initiation practices to reduce transmission risk. They used their authority to promote safe behaviors. When secret society leaders spoke, people listened in ways they didn't listen to government health workers. This demonstrated the importance of working with, not against, traditional power structures. Village task forces formed spontaneously in many communities. Volunteers took on roles as contact tracers, educators, and enforcement officers. They knew their communities intimately, who lived where, who was related to whom, who had traveled recently. This local knowledge was invaluable for contact tracing, far superior to outsiders trying to navigate complex social networks. Traditional healers, who initially were sometimes part of the problem, became part of the solution in many areas. Response teams trained them in infection prevention and taught them to recognize Ebola symptoms. Instead of treating suspected Ebola patients with traditional remedies, trained healers referred them to treatment centers while continuing to treat other illnesses safely. They became bridges between traditional and modern medicine. Women's groups mobilized to provide care for orphans and quarantined families. They cooked meals for isolated households, delivered supplies, and provided emotional support, all while maintaining safety protocols. The social solidarity that's characteristic of many African communities became a resource for epidemic control. Youth groups organized public education campaigns. Young people created songs about Ebola prevention that spread through communities. They performed skits demonstrating proper handwashing and safe burial practices. They used social media to share accurate information. Their energy and creativity made health education engaging rather than preachy. Community surveillance systems emerged. People reported unusual illnesses or deaths to local focal points, who connected with the formal health system. This created an early warning network that caught cases faster than relying only on facility-based surveillance. These grassroots responses weren't perfect. Sometimes they violated individual rights. Sometimes they scapegoated outsiders or marginalized groups. Sometimes they relied on traditional beliefs that conflicted with scientific understanding. But they demonstrated that communities have resources and resilience that outsiders often overlook. The most successful outbreak responses combined top-down resources, vaccines, treatments, expertise, funding, with bottom-up organization and local knowledge. When international teams worked in genuine partnership with communities rather than imposing solutions, outcomes improved. Feel a sense of warmth thinking about communities coming together to protect each other. Yes, there was fear and sometimes violence. But there was also solidarity, creativity, and courage. People taking care of their neighbors. Young people protecting elders. Communities marshaling their resources to face a common enemy. That's humanity at its best. Now let's talk about what Ebola has taught us about pandemic preparedness more broadly. The lessons extend far beyond this one virus. Early detection is everything. Every hour of delay in identifying an outbreak allows exponential spread. Investing in surveillance systems, laboratory capacity, and rapid response teams pays dividends far exceeding their cost. A few $1 million spent on surveillance can prevent billions in economic damage and thousands of deaths. Healthcare worker safety is paramount. In every major Ebola outbreak, healthcare workers were disproportionately affected. They're the frontline defense, and when they fall, the entire response crumbles. Proper protective equipment, training, and support must be non-negotiable. Hospitals should be places of healing, not amplifiers of disease. Community engagement cannot be an afterthought. Technical solutions fail without social acceptance. Communities must be involved from the start in designing responses. Their knowledge, concerns, and priorities must be heard and incorporated. Top-down imposition breeds resistance. Collaborative partnership builds trust and compliance. Equity matters operationally, not just morally. Diseases don't respect borders or social hierarchies. An outbreak among marginalized populations will eventually spread to everyone. Protecting the most vulnerable protects everyone. Leaving anyone behind endangers all of us. Scientific research must be sustained even between crises. The Ebola vaccine existed in concept for years before the West African epidemic, but wasn't developed because there was no market incentive. Waiting until an outbreak to start research means thousands die while science catches up. Sustained funding for vaccines and treatments for potential pandemic threats is essential. Global cooperation is necessary. Diseases that emerge anywhere can spread everywhere in our interconnected world. Rich countries cannot wall themselves off from poor countries' health problems. Global health security requires genuine global cooperation, not just self-interested aid. Information sharing must be rapid and transparent. During outbreaks, every day of delayed information sharing costs lives. Countries must be incentivized to report outbreaks quickly rather than hiding them to avoid economic or political consequences. The international health regulations provide a framework, but compliance is often lacking. Supply chains for medical countermeasures must be resilient. The scramble for protective equipment during both the Ebola and COVID-19 pandemics revealed dangerous fragility in global supply chains. Strategic stockpiles, diversified manufacturing, and surge capacity are necessary. One Health approaches are crucial. Ebola is a zoonotic disease, jumping from animals to humans. Most emerging infectious diseases share this origin. Preventing spillover requires understanding animal reservoirs, monitoring wildlife populations, regulating wildlife trade and consumption, and managing human encroachment into wild spaces. Human health, animal health, and environmental health are inseparable. Climate change is a threat multiplier. Changing temperatures and precipitation patterns alter animal habitats and behaviors, increasing human-wildlife contact and spillover risk. Vector-borne diseases expand into new territories. Extreme weather damages health infrastructure. Climate mitigation and adaptation are public health imperatives. Mental health support must be integrated into emergency responses. The psychological trauma of epidemics is profound and long-lasting. Healthcare workers, survivors, bereaved families, and whole communities need mental health services. These cannot be afterthoughts but must be built into response plans from the beginning. Economic support for affected populations is necessary for compliance. Quarantines and movement restrictions impose severe economic hardship. People who can't feed their families if they don't work won't comply with quarantines, no matter how deadly the disease. Economic support, cash transfers, food assistance, job protection, must accompany public health measures. Let these lessons settle into your consciousness. They're written in the blood of 15,000 Ebola victims and millions of COVID-19 deaths. Lessons we've learned at tremendous cost. The question is whether we'll remember them when the next crisis comes, or whether we'll forget and relearn them at terrible cost once again. For now, just hold the knowledge. Let it inform your understanding of the world you're part of. If you're still listening, still engaged with this long journey through Ebola's history, I'm grateful. Subscribe to Dreamless Timelines to support more content like this. Like this video if it's providing value. Comment with your reflections. These small acts of engagement make a real difference. Let me tell you about some of the technological innovations that emerged from Ebola research and response. Portable diagnostic laboratories were developed specifically for Ebola outbreaks. These labs in a box can be deployed anywhere and provide sophisticated testing capacity in the field. They've since been used for COVID-19, Lassa fever, and other diseases. The technology transfer from Ebola response to broader infectious disease control has been significant. New personal protective equipment designs emerged. The traditional hazmat suits used in early outbreaks were dangerous in tropical heat. Engineers designed suits with better ventilation, cooling systems, and improved mobility. Some experimental designs included battery-powered air circulation. These innovations benefit not just Ebola responders but anyone working in high-risk environments. Cold chain technologies improved. The Ebola vaccine requires ultra-cold storage, a challenge in areas without reliable electricity. Solar-powered refrigerators, portable ultra-cold freezers, and better insulated transport containers were developed or improved. These technologies now help deliver vaccines and temperature-sensitive medications to remote areas for various diseases. Telemedicine platforms expanded. During outbreaks, remote consultation reduced the number of people who needed to enter high-risk areas. Doctors could examine patients via video, review lab results remotely, and provide guidance without physical presence. This technology has since been adopted widely, accelerating a shift to virtual healthcare that COVID-19 further amplified. Data management systems became more sophisticated. Contact tracing for thousands of people generates enormous amounts of data. Software designed for Ebola contact tracing has been adapted for other diseases and for general public health surveillance. The principles of rapid data collection, analysis, and action learned from Ebola inform modern public health informatics. Experimental treatment platforms were validated. The clinical trials of monoclonal antibodies during the North Kivu outbreak demonstrated that rigorous research could be conducted even in conflict zones during active epidemics. The adaptive trial designs used, where multiple treatments are compared simultaneously and ineffective ones are dropped while the trial continues, have been adopted for other diseases. Community engagement technologies evolved. Mobile phone-based surveys, interactive voice response systems, and SMS-based education campaigns were pioneered or refined during Ebola responses. These tools allow rapid assessment of community knowledge, attitudes, and practices, enabling real-time adaptation of public health messaging. Safe burial technologies improved. Body bags designed to be leak-proof and easily decontaminated were developed. Mobile cremation units were deployed in some outbreaks. While cremation conflicted with many cultural practices, the technology existed for situations where it was necessary. The ethical and cultural considerations around body management in epidemics were extensively debated and documented. Disinfection technologies advanced. Chlorine sprayers designed for Ebola response have been used in various settings. UV-based disinfection systems for air and surfaces were refined. Understanding of which disinfectants work against enveloped viruses like Ebola informed cleaning protocols in hospitals and other facilities. Vaccine distribution strategies were innovated. The ring vaccination approach used in Ebola outbreaks, vaccinating contacts of cases to create protective rings around infection, proved highly effective and has been adopted for other diseases. This targeted approach uses limited vaccine supplies efficiently and provides natural experiment conditions to assess vaccine effectiveness. Imagine the cascade of benefits flowing from tragedy. Technology developed for one crisis becoming tools for many others. Knowledge gained from suffering informing better responses to future suffering. It doesn't justify the deaths. Nothing could. But it means those who died contributed, however unwillingly, to a body of knowledge that saves future lives. Perhaps there's cold comfort in that. The cultural impact of Ebola extends beyond the immediate affected communities. The disease entered global consciousness in ways that shape how we think about infectious disease risk. Movies and television shows featuring Ebola increased dramatically after the West African epidemic. Films like Contagion saw renewed interest. Books about epidemics became bestsellers. The 1995 film Outbreak was rediscovered by new audiences. These fictional portrayals, while often sensationalized, raised public awareness about pandemic threats. The imagery of Ebola became iconic. Healthcare workers in full protective suits, isolated treatment centers, body bags. These images symbolize epidemic danger in the public imagination. They shaped expectations about what pandemic response looks like, for better and worse. When COVID-19 arrived, people expected to see hazmat suits and were confused by the focus on simple masks. Ebola changed how we talk about disease preparedness. Terms like outbreak, epidemic, and pandemic entered common vocabulary. Concepts like R0, the basic reproduction number of a disease, and case fatality rate became familiar to non-specialists. This linguistic shift reflects increased public engagement with infectious disease issues. The virus became a metaphor in political and cultural discourse. People describe ideas or problems as spreading like Ebola. The language of contagion permeates discussions of social phenomena, from radicalization to misinformation to cultural trends. This metaphorical usage reveals anxiety about things spiraling out of control. Ebola influenced art and literature. Writers and artists from affected countries created works processing the trauma and examining the social impacts. These artistic responses document the human experience in ways that statistics and scientific papers cannot. They preserve emotional truth alongside factual truth. The epidemic changed career trajectories. Many young people, inspired or horrified by what they witnessed, went into public health, epidemiology, or infectious disease medicine. The next generation of disease fighters includes many who were motivated by Ebola. The epidemic created its own cadre of experts who carry forward the lessons learned. Survivor communities developed distinct identities. Being an Ebola survivor means something. It's a shared experience that bonds people across geographic and ethnic lines. Survivor associations have become political and social forces, advocating for resources and respect. They've built solidarity from suffering. In affected countries, the epidemic became a historical marker. Time is referenced as before Ebola or after Ebola. The epidemic divided history into two eras, much as wars or natural disasters do. This linguistic and conceptual division reflects the profound disruption the epidemic caused. Consider how trauma reshapes collective consciousness. How shared suffering creates communities. How crisis moments become reference points that define eras. Ebola is now part of the historical narrative of West Africa and the Democratic Republic of Congo, an event that will be remembered for generations, taught to children, commemorated in memorials. The dead are gone, but their impact on the living continues. Let's discuss the economic recovery and rebuilding that followed the West African epidemic. This part of the story gets less attention but matters enormously. When the epidemic ended, the three most affected countries faced monumental reconstruction challenges. Healthcare systems needed to be rebuilt from scratch. Public confidence in those systems needed to be restored. Economic activity needed to restart. Social fabric needed to be rewoven. Healthcare reconstruction required massive investment. Hospitals and clinics needed renovating or replacing. Equipment needed to be purchased. Most challenging, the healthcare workforce needed to be reconstituted and trained. With hundreds of doctors and nurses dead, there were enormous gaps in expertise. Training new healthcare workers takes years. In the meantime, countries made do with skeleton staffs and foreign volunteers. International donors pledged billions for recovery. The World Bank, African Development Bank, European Union, United States, and other donors committed funds. But pledges and actual delivery are different things. Disbursement was slow. Bureaucracy delayed implementation. Much promised money never materialized or arrived years late when the acute need had passed. Some reconstruction efforts succeeded. New hospitals were built with better infection control infrastructure. The newly built Eternal Love-winning Africa Hospital in Liberia, for example, incorporated lessons from the epidemic, with isolation facilities and proper protective equipment from the start. Training programs improved healthcare workers' skills in infection prevention. Other efforts fell short. Corruption diverted some funds. Poorly planned projects failed. Foreign aid came with strings attached that didn't match local priorities. The gap between what was promised and what was delivered bred cynicism and resentment. Economic recovery was uneven. Urban areas and capital cities bounced back faster than rural areas. Certain sectors, telecommunications, some services, recovered quickly. Others, tourism, small-scale agriculture, struggled for years. The epidemic widened existing inequalities rather than narrowing them. School systems faced enormous challenges. The extended closures had created a lost generation of students. When schools reopened, many students had forgotten material. Some had dropped out permanently. Teachers had died or left the profession. School infrastructure had deteriorated during the closure. Getting education back on track required years of intensive effort. Orphans created by the epidemic needed care. Extended family systems absorbed many, as is traditional. But tens of thousands of children lost both parents. Some were taken in by relatives who struggled with the additional burden. Others ended up in orphanages or on the streets. The psychological trauma these children carried would affect them lifelong. Social trust needed rebuilding. The epidemic had fractured communities. Suspicions and accusations lingered. Families who'd been quarantined were stigmatized. Healthcare workers who'd survived were sometimes ostracized. Rebuilding social cohesion required conscious effort, community dialogues, reconciliation processes, shared rebuilding projects. Memorials were constructed to honor the dead. In Monrovia, a memorial garden was created. In Freetown, plaques commemorated fallen healthcare workers. These physical spaces provided places for grief and remembrance. They acknowledged that something terrible had happened and that those who died deserved to be remembered. Survivor support programs had mixed success. Some survivors received counseling, medical follow-up, and economic assistance. Others received nothing. The variation depended on location, available resources, and organizational capacity. Many survivors still deal with chronic health issues and economic hardship years later without adequate support. International attention moved on quickly. While affected countries were still struggling with recovery, global media and donors shifted focus to other crises. Syria, Yemen, the refugee crisis in Europe, Venezuela. The world's attention span is short. Once the acute emergency passed, interest faded. Reflect on this pattern. The world pays attention during crisis, then forgets during the long, hard work of recovery. Disasters are dramatic. Rebuilding is boring. But rebuilding is where the real work happens, where communities heal or don't, where lessons are institutionalized or lost. The unglamorous aftermath matters more than the dramatic peak, but it's harder to sustain interest in. Subscribe to Dreamless Timelines if you appreciate this depth of historical exploration. Like this video. Comment below. Your engagement is what makes this possible. Now let's talk about what the future holds. What can we expect from Ebola in the coming years and decades? More outbreaks are certain. The virus exists in nature and will continue spilling over into human populations periodically. The question isn't if, but when and where. Deforestation, climate change, and population growth all increase spillover risk. The Democratic Republic of Congo will likely continue seeing outbreaks. The country has experienced more Ebola outbreaks than any other, over a dozen since the virus was discovered. The combination of extensive rainforest, high bat populations, bushmeat hunting, and fragile healthcare systems creates ongoing vulnerability. West Africa may see more cases. The 2014-2016 epidemic wasn't the region's last encounter with Ebola. The virus is present in bat populations across West and Central Africa. Future spillovers anywhere in that range are possible. Unknown strains may emerge. We've identified 5 species of Ebola virus so far. There may be others. The viral diversity in bat populations likely exceeds what we've detected in human outbreaks. New strains with different characteristics, higher or lower mortality, different transmission patterns, could emerge. Climate change may alter outbreak patterns. As temperatures rise and precipitation patterns shift, bat ranges will change. Species may move into new areas, bringing the virus to places that have never experienced it. Predicting exactly how this will play out is difficult, but increased human-wildlife contact seems likely. Urbanization creates new risks. If a future outbreak begins in a major city rather than a rural area, the dynamics could be very different. Rapid spread through dense populations. Overwhelmed healthcare systems. Potential for international spread via air travel. The nightmare scenario planners worry about is Ebola in Lagos, Nairobi, or Kinshasa before it's detected and contained. But there's also reason for optimism. We're better prepared than ever before. The vaccine works. Treatments improve survival. Surveillance systems can detect outbreaks faster. Response protocols are established and tested. Each outbreak teaches lessons that make us better at handling the next one. Vaccine coverage may expand. Currently, the vaccine is used in outbreak response, ring vaccination around known cases. Future strategies might include preventive vaccination of high-risk populations, healthcare workers, bushmeat hunters, people living near bat colonies. This would create immunity barriers that prevent or limit outbreaks. New vaccines are in development. Vaccines for Sudan and Bundibugyo strains are in clinical trials. A universal Ebola vaccine that protects against all strains is a research goal. Such a vaccine would be a game changer, providing comprehensive protection regardless of which strain emerges. Treatment will continue improving. The monoclonal antibodies that exist now are first-generation therapies. Second- and third-generation treatments will be more effective, with fewer side effects and easier administration. Antiviral drugs that directly inhibit viral replication are being developed. The vision is to make Ebola a treatable disease with high survival rates. Rapid diagnostics will get better. The goal is point-of-care tests that provide results in minutes without laboratory equipment. Imagine a healthcare worker in a remote clinic being able to diagnose Ebola from a finger prick blood sample in the time it takes to diagnose malaria. That technology is coming. Artificial intelligence and machine learning will enhance surveillance and prediction. Algorithms can analyze vast amounts of data, wildlife populations, climate patterns, human behavior, disease reports, to predict where outbreaks are likely to occur. Early warning systems could alert health authorities to emerging threats before human cases appear. Global health security initiatives are strengthening capacity worldwide. Countries are investing in laboratory networks, emergency response teams, and surveillance systems. The infrastructure being built for pandemic preparedness benefits Ebola control as well as defense against other threats. The One Health movement is gaining traction. This approach recognizes that human, animal, and environmental health are interconnected. By monitoring wildlife populations, regulating bushmeat markets, protecting ecosystems, and improving livestock management, we can reduce spillover risk for Ebola and many other zoonotic diseases. International cooperation frameworks are improving, albeit slowly. The World Health Organization's Health Emergencies Program was created in response to the Ebola epidemic. Regional organizations like the Africa CDC enhance coordination. Cross-border collaboration is increasing. Let yourself feel cautiously hopeful. Yes, more outbreaks will come. Yes, people will die. But fewer will die than would have a decade ago. We're learning, improving, building systems and knowledge that protect more people. Progress is real, even if it's incomplete. That's worth acknowledging as you drift deeper into rest. Let me share some final stories of individuals whose lives were changed by Ebola in unexpected ways. Iris Marteyer was a nurse from Florida who volunteered with Samaritan's Purse in Liberia during the epidemic. She cared for Ebola patients for months without becoming infected herself. When she returned to the United States, she was quarantined due to excessive state-level precautions, despite being asymptomatic and low risk. The experience radicalized her. She became an advocate for rational, science-based public health policy and for healthcare worker rights. She testified before Congress about the stigma and mistreatment healthcare workers faced. Her advocacy helped shift policies. Yusuf Kaba was a 12-year-old boy in Sierra Leone who lost both parents and his sister to Ebola. He survived the disease himself and was left alone. A local NGO helped him get back into school and provided psychological support. He became determined to become a doctor to fight diseases like Ebola. Years later, he's in medical school, working toward his goal. His story is one of resilience turning trauma into purpose. Dr. Masoka Falla was a Liberian epidemiologist who ran contact tracing efforts during the epidemic. He trained thousands of contact tracers and managed massive data collection efforts. His work was crucial in containing the outbreak in Liberia. After the epidemic, he became a global expert on contact tracing. When COVID-19 emerged, he shared Liberia's lessons with countries worldwide. He advised governments on contact tracing strategies. His expertise, born from Ebola, saved lives in a different pandemic. Fatima Dafuer was a contact tracer in Sierra Leone. She walked miles each day through difficult terrain to check on people who'd been exposed to Ebola. She faced rejection, suspicion, and sometimes threats. But she persisted because she believed in the work. After the epidemic ended, she used the skills she'd learned to become a community health worker, providing primary health care in her region. The epidemic gave her training and purpose that changed her life trajectory. Will Pooley was a British nurse working in Sierra Leone who contracted Ebola. He was evacuated to the UK for treatment with experimental therapies. He survived and, remarkably, returned to Sierra Leone to continue fighting the epidemic. His return boosted morale and demonstrated that Ebola could be survived and didn't have to end careers. After the epidemic, he became an advocate for global health equity and continued working in low-resource settings. These individuals represent thousands whose lives intersected with Ebola and who were changed by the encounter. Some became advocates. Some became experts. Some found purpose in tragedy. Their stories remind us that history isn't just big events and statistics, it's individual humans whose paths cross with momentous things and who choose how to respond. As you listen to these stories, feel the thread connecting them. Ordinary people confronting extraordinary circumstances. Some through choice, some through chance. All responding with courage, resilience, or transformation. We're all just one crisis away from discovering what we're made of. Let that thought be both sobering and inspiring as you relax into the darkness. Make sure you're subscribed to Dreamless Timelines. Hit that like button if this marathon journey through Ebola's history has been worthwhile. Comment below with your takeaways or reflections. And share this with anyone who appreciates deep, thoughtful historical content. Now, let's bring this story to its close. Today, in 2025, The world is a different place than it was in 1976 when Ebola first emerged. We have tools, knowledge, and systems that make the virus less terrifying than it once was. Not harmless, never harmless, but manageable. The vaccine that's 100% effective stands as testament to what science can achieve when properly funded and motivated. The treatments that increase survival rates demonstrate progress. The surveillance systems that detect outbreaks quickly show we're learning from past failures. But challenges remain. The vaccine only covers one strain. Treatment is expensive and requires infrastructure many places lack. Surveillance only works where health systems function. The hardest-hit areas often have the weakest systems. Inequality remains the fundamental challenge. Ebola disproportionately affects poor people in poor countries with weak governance and inadequate healthcare. Until we address these root causes, outbreaks will continue and responses will struggle. The lessons Ebola teaches us extend far beyond one virus. They're lessons about how interconnected our world is. About how public health failures anywhere threaten health everywhere. About how historical trauma shapes present responses. About how trust matters as much as technology. About how equity isn't just a moral issue but a practical necessity for effective epidemic control. COVID-19 validated many lessons learned from Ebola and exposed how many others we'd failed to internalize. The importance of early detection. The value of community engagement. The necessity of protecting healthcare workers. The dangers of misinformation. The challenge of vaccine hesitancy. The inequity of access to medical countermeasures. Ebola taught us all of this. COVID-19 tested whether we'd learned. In some ways we did better with COVID-19 because of Ebola. We developed vaccines faster. We understood the importance of contact tracing. We had better protective equipment designs. But in other ways we repeated mistakes. We were slow to respond. We prioritized rich countries over poor ones. We politicized public health. We didn't invest enough in preparedness between crises. The next pandemic is coming. Maybe it's another Ebola outbreak that gets out of control. Maybe it's a different virus entirely. Disease X, the unknown pathogen on the WHO priority list. The question is whether we'll be ready. Whether we'll have learned the lessons bought with 15,000 Ebola deaths and millions of COVID-19 deaths. Whether we'll invest in prevention and preparedness or continue to scramble during crises. The answer depends on choices made today. Political choices about funding public health infrastructure. Economic choices about prioritizing long-term safety over short-term profit. Social choices about valuing all human lives equally. Scientific choices about which research to pursue. Individual choices about trusting expertise and caring for community welfare. Ebola's story isn't over. The virus is still out there, in its bat reservoirs, waiting for the next spillover. More outbreaks will come. More people will die. But if we apply what we've learned, fewer will die. If we build better systems, invest in capacity, address inequities, and remember the lessons, we can bend the curve toward a safer future. The 15,000 people who died from Ebola between 1976 and today didn't die in vain if their deaths teach us how to save future lives. The healthcare workers who risked and sometimes lost their lives fighting the virus showed us what courage and dedication look like. The survivors who rebuilt their lives and helped others demonstrate human resilience. The researchers who developed vaccines and treatments proved that science can triumph over nature's deadliest weapons. This history is dark, full of suffering and death. But it's also full of heroism, innovation, compassion, and hope. It's a story about humanity at its worst and its best. About the fragility of life and the strength of the human spirit. About death and survival. About fear and courage. About the past and the future. Take a deep breath. Hold it. Release it slowly. You've journeyed through 50 years of history, through thousands of deaths, through countless stories of suffering and heroism. You've walked through the shadows of Central African rainforests and into the isolation wards where people fought for their lives. You've met the virus that kills with merciless efficiency and the humans who fight it with stubborn determination. As you close your eyes and let sleep take you, carry this knowledge with you. The world is dangerous, yes. Nature holds terrors we can barely comprehend. But we're not helpless. We can learn. We can prepare. We can care for each other. We can build systems that protect the vulnerable. We can turn tragedy into wisdom. Ebola taught us that we're fragile, but it also taught us that we're strong. That knowledge doesn't make the darkness disappear, but it makes it bearable. And sometimes, on the other side of darkness, there's dawn. Sleep now. Rest in the knowledge of what came before and what might come after. Dream, if you dream, of a world where fewer people die from preventable causes. Where science and compassion triumph over disease and despair. Where we remember the lessons bought with blood and build something better. The story of Ebola continues. But for now, for tonight, your part is simply to rest. To let this history settle into your bones. To sleep, knowing that tomorrow, somewhere, people are working to make the world safer. That's enough. That has to be enough. Good night. Sleep well. And thank you for taking this journey through one of humanity's darkest encounters with nature. May we all wake to a brighter dawn.